my dear students, welcome to Deeksha Karnataka YouTube channel, and today I am going to discuss the one of the most important chapters for your PU2 as well as KCET preparation, that is electric charges and fields, right? So here you are, those who are here, please say hi in the chat, then I can start today's class. Just let me check if it is working. Yes, it is working. So if you are watching right now, please say hi in the chat so that we can continue. And remember that I am going to discuss everything in detail, all the chapter concept, as well as we will also going to solve a lot of questions. So be with me till the end, right? So let's start. First, we will see why this chapter is important. You are seeing that, okay, the chapter is important, sir is saying this chapter is important, but why this chapter is important? So let's see the topics, important topics: properties of electric charges, Coulomb's law, electric field, properties of electric field lines, electric field due to a dipole, Gauss law, electric field due to a long straight wire, and electric field due to spherical shell. These are all the important concepts, but we are going to cover the entire chapter, but these concepts are one of the most important concepts, and from these concepts we are going to get repeated questions. Now if you see the blueprint of your PUC, you will see that the total marks allotted for this chapter is 11, which is very high, because you can score 11 marks if you study this chapter properly. That means your PUC gives this a very high weighted chapter. And in KCET, if you see that average number of question, so 4, 5, 3, 4, 4, 4. So average number of questions that is coming from this chapter is 4. Okay, so we can expect 4 questions that might come from this chapter, and that is overall, except 1 year that was 1 more, 1 year it is 1 less, but on an average we are getting 4 questions from this chapter. So from this chapter, again, that's why we are saying this is a very, very, very important chapter. Now we have done one exercise ourselves where we have studied all the concepts that is coming year after year in your PUC exam. So in the PUC exam, as you can see, Coulomb's law has came almost every year except 2024. So one question related to Coulomb's law. It can be 1 marker, it can be 5 marker, it can be 3 marker or 2 marker. So total number of questions that came from Coulomb's law is 4. So this is one of the highest weightage topic. Electric field and application, electric field, properties of electric field, questions related to electric field, that came 3 times. Now properties of electric field lines, this is a separate one, because this is one of the most asked question. So properties of electric field line, if you are preparing for PUC, obviously this is the most important concept, and as you can see, this came 4 times in last almost 5 years, right? Electric field due to a long straight wire came once, and electric field to a spherical shell came once. This is a numerical question. I don't remember about this one, but this one was a numerical question based on this concept. Okay, so numerical question as well as theoretical question, both can come from this chapter. This year there is a chance that the 5 marker question that is coming from this chapter will not be a numerical but be a theory question. So be prepared both way, okay? And there are 3, you all know that there are 3 exams. So if you are preparing for at least first 2 exams, then you should remember that maybe if you are preparing for 2 exams, one exam there might be a theory, in another exam there might be a numerical question. So you have to prepare both. You cannot skip this chapter. You have to complete this chapter as a whole. Let's see some comments. Hi, good evening, Pradyum, Ojas, hi. Sir, will you solve full PYQ? Ojas, not all PYQs, but very important PYQs we are going to solve. If you want the full PYQ, we have done another series. There you can check top 30 PYQs as well as our Sankalp series. This chapter was covered in whole, so you can go and check that as well. All KCET PYQs are solved. I am going to discuss some very important question as well as some sample problems as well. So if you are preparing, stay till the end. At the end, once the chapter is over, we are going to solve some sample questions as well, right? So let's start. First, we will start with the basics of electric charge. This chapter is about electric charges. Sir, when sir you will do KCET one shot? Mano, we will start soon. KCET one shot will also be there. So don't worry, if you are waiting for KCET one shot, that will also be done. But today we are not only doing KCET, but we are also doing PUC as well. So those who are preparing for PUC and KCET, this is the must have lecture, okay? Because we will also cover KCET in a separate lecture where only KCET related topics, KCET related concepts are discussed. But today we are going to discuss from basics. Those students who have some trouble understanding the basics, the chapter was done long back in your classes, and now you have almost either forgotten everything or you have some difficulty in the basics, and now you are struggling with this concept, then definitely this will going to help you for PUC as well as your KCET exam. Right? Nikhil is saying waiting for chemistry class is tomorrow, so don't miss out on the class. Saini ma'am will take. So when you complete KCET syllabus, Ojas Kiran, that's why we are started here. This is just a starting, just the beginning of a long range of series which are going to follow up next. So we will also cover the KCET syllabus, don't worry about it, okay? So KCET syllabus will also be covered. I am Ojasvi. Okay, Ojasvi. Model paper is already done, Prema. Sir, can you suggest a book for KCET? Noob Angle, if you want a book, but book is right now I don't recommend any book, because book should be started, you should have started at the beginning of the year. MTG book, which is very, very fat and lengthy book, you will not be able to complete that book right now, but I will recommend something throughout the lecture, so stay tuned for that. Okay, so let's see. So we know that how many types of charges are there? There are basically two types of charges. One charge is positive, another one is, we call it negative. But what is charge? What is positive and negative means actually? So positive and negative are the charges that basically comes from one atom. Okay, atom, and what atom consists of? Atom has electrons and protons. Okay. But before going into that, let's discuss one of the basic properties. Like charges repel each other and unlike charges attract each other, right? So unlike charges, positive and negative, they will attract. Positive, positive, negative, negative, they will repel each other. Okay. Now, as I was discussing that, what is the source of charge? So basically, the source of charge is atom. The structure of atom is the source of charge. Okay, each atom consists of what? Each atom consists of positively charged protons, which are located at the nucleus, and negatively charged electron, which are orbiting around the nucleus. Right? Now, when you consider the structure of an atom, the positively charged nucleus and electrons are orbiting around it. Now, if I want to break the nucleus, okay, it is very, very hard for me to break this nucleus. Okay, nucleus is one of the, is protected by one of the most strongest force in nature, that is nuclear force. So I will not be able to break this nucleus easily and take out the positive charge. But the electron, which is orbiting around this positively charged nucleus, I can easily remove one of them. One or two of them I can easily remove. Okay, in chemical reactions also this happens. In physical process also, by rubbing or by some other electrolysis process, you can remove the electron. Okay, once this electron is removed, what we got? We got a positively one extra positive charge. Okay, there are other electrons as well. There may be not only one electron. The orbit may have more than one electron, but there is a one electron less in this. So one electron less means initially the total number of protons and total number of electrons was equal. So the atom was neutral in nature. Now if you separate one electron from the atom, okay, once you separate the electron from the atom, what you get is the positively charged ion and one negatively charged electron. This electron actually gives rise to charge. This is the major culprit. So if electron was very tightly bound with the atom, then this chapter was not existing. Okay, you would not have studied this chapter at all if the separation of electron was not possible, and many other things would not have been possible, right? So because electron can be separated from the atom, okay, that's why we can charge something with positive and negative. Positive means basically it has one less electron, negative means it has one, the electron itself is negative, okay. So only electron can be added or removed to charge any object. So if in some cases you can even add one extra electron as well, okay. So if you can add that extra electron, okay, then it becomes negative, the atom itself becomes negatively charged, okay. So electrons can be added or removed. Only remember, this is very very important point to remember, and based on this you might get a new objective question in your PUC exam as well. So only electrons can be added or removed, right. If electrons are added to a body, it gets negatively charged, and if electrons are removed, the body gets positively charged, okay. Sir, will you solve numericals? Yes, Prema, I will be solving everything, whatever is required for your PUC as well as your KCET. I will cover everything, including numericals for your PUC exam, including questions for your PUC exam, objective questions. Also, I will tell you what, if a long form question comes, what you have to write, everything I will say, okay. So don't worry about it, okay. Every part of the chapter will be covered. I have not mentioned the long form questions in this lecture, but if you want, I can add that in the PDF. So once you download, also I will be sharing the formula sheet for this chapter. So everything will be covered, okay. So not only the lecture is important, the PDF also very very important, because in this PDF you will get the formula sheet that is there at the end of the lecture. Once the lecture is over, I will show you the formula sheet and how to use it. Then you can download the lecture PDF and you can get the formula sheet itself, okay. Duration of this lecture, Prema, it will minimum be 2 hours. So take your cup of tea, take your snacks and sit together. Bring your notebook and pen if you want to note something, and then you should sit, okay. Sir, point 7b, the body becomes positive, right? Point 7, if electrons are removed, the body becomes, yes, positively. This will be positively, sorry, this will be positive. Okay, so if you are removing the electron, then the body becomes positively charged. If you are adding extra electron, the body becomes negatively charged, okay. Now there are some instruments based on this. We have seen some objective question in the past. Gold leaf electroscope is a device that can measure the presence of charge. It cannot measure the amount of charge, okay. It can only measure whether an object is charged or not, okay. It can only measure the presence of charge, okay. How charge is measured, that is a completely different topic that I am not going to discuss in today's lecture. So gold leaf electroscope is the device which is used to measure the presence of charge. Now you may have studied it in your lower classes, 6th, 7th and 8th. There are a lot of experiment based on gold leaf electroscope. It was present in your PUC as well few years back, but now it is almost removed. Only the part which is mentioned in your textbooks is that gold leaf electroscopes are the device that is used to measure the presence. So if there is a question that the following device is used to measure the presence of an electric charge, and there are a lot of options are given, you have to choose gold leaf electroscope. SI unit of charge is Coulomb. We already know that this is after the Coulomb's law. So because he gave the Coulomb's law later on when the charge was discovered, and once the electrons etc. is discovered. And remember one thing, when the theory of this was discussed, okay, the electrons and protons are completely unknown. Okay, even without knowing the exact nature of charges, the theory was developed. Okay, Coulomb's law, when by the time Coulomb gave his theory, we are not at all aware of electrons, protons, structure of atoms, etc. Okay, so atoms was considered to be indestructible, and there are some theories back then which is completely obsolete right now. So that is also I am not going to discuss. But this theoretical portion, initially whatever we are going to discuss, Coulomb's law, electric field, etc., they were completely manufactured or studied without knowing what is causing it. Okay. So SI unit of charge is Coulomb. When the charge was discovered, when the electrons are discovered, charges are measured, then the name was given after the first pioneer of this field, Coulomb. Okay, dimensions of charge is A into time. A is dimension of current and time is the dimension of time, obviously. Now charge is not considered a fundamental quantity, current is a fundamental quantity, that's why it is coming as current into time. Okay, so these are the important points to remember. Okay, and trust me, some cases we have seen questions like which is the following is the unit of charge. We have seen this type of question in PUC exam. Okay, now so properties of electric charge, very important. Komal Kaushik, 65 in 70. Congratulations, Komal. Anjali, is it also functions of gold leaf electroscope? Functions of gold leaf electroscope is not part of the syllabus. If you want, I can discuss it briefly. So gold leaf electroscope basically has a very simple mechanism. There is a round structure like that. I cannot draw it in a 3D, so I will draw it simple straight line, but it is a round disc. Okay, from there is a conductor. Okay, conducting wire is there, and gold leaf, which is basically made by a single thin gold foil. It is cut into two pieces, and those two pieces are actually hanging from here. Normally, if you see that, you will see that gold leaf, two leaves are stuck together. Okay, they are just like this. Two leaves are normally just like this, and there is an insulating glass surface, and the outer surface is grounded. Now, when you brought a charged object over here, due to induction, it gets negatively charged. Okay, the near side and the far side gets positively charged, and once it is happening, okay, because positive charges repel each other, so you get a deflection of the leaves. That's how the gold leaf electroscope, if there is a deflection, you will know that okay, the object that you have brought is a charged object. If the gold leaf remains same without any extra deflection, that means the object that you have brought in has zero charge. Now if you see that when it is happening, you can consider this as a gold leaf. Now because you have not touched the system, then in that case the total charge of the gold leaf is still zero. If you remove this object, then the gold leaves will still go back to its original position. So I have seen one very old KCET question when the question was, you brought a positively charged object nearer to a gold leaf electroscope and the object is removed, the total charge of the gold leaf is positive, negative, does not matter, etc., but it should be, answer should be zero. So very easy question, but still sometimes student gets confused. So remember, if the object is not touched, then total charge of the gold leaf will still be zero. If the object is touched with this round shape, then the gold leaf will acquire the charges from this object and entire gold leaf will be positively charged. So remember this is a very small trick, small important concept that students tend to forget. Okay, so if you are not touching, the object can be considered as an isolated system, and in isolated system total charge remains conserved. We will see that in our next part. Okay, and because it's an isolated system, the total charge will still be zero in the gold leaf electroscope. If you touch it, then it is no longer an isolated system. You are touching with the already charged object, so the charges will be transferred and the gold leaf will be charged. Okay. Sir, asking for WhatsApp channel link for past few days. Pradyum, you can go to any of our videos and check in the description section. There is something called description section where you get an option like read more. You can get it from this live as well. Okay, you have to go, if you are watching it in your browser, close the live chat, or live chat will be appearing on your right hand side. On the bottom part of the lecture, you will see a description, okay, where you will get a read more option. Click on the read more option, scroll down, you will find the link to join our WhatsApp channel. Okay, the WhatsApp channel description is there in each and every videos of our channel. So if you are still confused, go back. If you are not able to access, if you are watching this from your mobile phone, it might not come directly. You have to wait till the live is over. So what you can do, you can pause this video for some time. You can go to another video, go to the description of that video, click on the read more option, and then you scroll, you will find WhatsApp link, joining link. click on that, your WhatsApp will open automatically and you will see our Deeksha Karnataka YouTube channel. You have to click follow that so that you don't lose it later on. Okay, once you click on the link, you have to follow. So once you follow, it will always appear in your feeds, in your WhatsApp feeds. It will not disturb you, obviously. It will always appear in your feeds whenever we are going live, whenever we are sharing some links. So don't miss out. Anyone like Pradyum, if you are still struggling, you can join our WhatsApp channel. Okay, our admin has shared the link. You can join the WhatsApp channel from there as well. It is also help to detect the charge and nature of charge, correct or wrong. Yes, Anuja, Anuanjan, yes, it can detect the type of charge as well. Measurement is not possible. It will help to detect the charge, and it will also be helpful. There is a specific method for that. Okay, you can. I am getting a call. I don't know from whom, so I am disconnecting that call. Okay, so what I can say that, so when the object is, if the gold leaf electroscope is pre-charged, just a second guys, I have a call. I don't know, someone is repeatedly calling me. Just give me a second. Hello. Sorry for just some guy called me. So just for your convenience, if the gold leaf electroscope is already charged, pre-charged, then you can detect the type of the charge as well, but those part is not part of the syllabus, by the way. So if you are seeing some question, maybe it is an out of syllabus question, yes, it can detect the type of charge as well, whether it is a positive or negative. Also it can detect whether the object is charged or not. There is a process for that as well. Okay, anyway, now properties of electric charge, this is one of the important question. It might come in your pre-board too, as well as in your final exam. So write 3 basic properties of electric charge. That is the question. Now I have seen the students, they are writing charges are additive in nature, charges are conservative, charges are quantized. If you write these 3 lines, you will lose marks. Okay, unless you are a very weak student, you are just about to fail in the exam, the teacher might consider give you full marks if that full marks gives you passing marks. Otherwise, if you are someone who is aspiring to score out of out, don't just write 1 line answer. The teacher are expecting from you that you should at least explain with 1 line. What is the 1 line? You can either add charges can be added algebraically, and you can show 1 example of that, and then charges is a scalar quantity. If you don't want to show the example, that is fine, but you have to mention charges can be added algebraically and charges are scalar quantity. So if you mention these 2 things, then this point will be considered as a correct answer. Okay, second, charges are conserved. Now what is the meaning of that? I already explained you once that total charge of an isolated system, this is very, very important. Total charge of an isolated system is always constant. Total charge of an isolated system is always constant. Sanjana, I got 60 out of 70 in physics. Please help to increase the marks. Definitely, Sanjana, you have to stay together. I got 62 marks in T-board. Very good, Ojas. Yes, Sanskar Power, I have to read the comments as well, that's why it might take some time, but I will try to cover the chapter as quickly as possible. Okay, and if you have any doubt related to the chapter, please mention that in the comment below. I will try to check it from time to time. If your comment is not answered immediately, please wait for a few minutes, because I will complete the concept, then only I will move into your comments. Charges are conserved. The total charge of an isolated system is always constant. Okay, so isolated system means which has no connection with outside. So outside means, suppose I have an object which does not communicate with outside, then it is called an isolated system. But if you bring something from outside, then it is no longer an isolated system, it is an open system. So there are few types of systems, okay, open system, completely open system, one side open system, isolated system, okay. If you are interested, I can discuss it in a little bit more in a separate video, but for this you should know isolated system means where it does not communicate with anyone else. So whatever inside, that is same. Now in isolated system, total number of positive and negative charge can increase or decrease, but overall, okay, the total charge should be constant. Okay, so if originally the charge inside the system was 10 Coulomb, then it will remain 10 Coulomb. Now maybe there was positive 1 Coulomb in the past and positive say 12 Coulomb in the past and say negative 2 Coulomb in the past. So initially that was the system. These 12 and minus 2 can change, but the overall charge should not change. Okay, so this plus 12 can go to plus 14. Okay, this plus 12 can go to plus 14, and it will be balanced by this negative charge. It can go to minus 4 Coulomb. Charges can be created or destroyed. Okay, charges, but in an isolated system, charge is conserved. Okay, if the system is not isolated, charge is not conserved. Remember that. Unlike mass, okay, if the system is not isolated, the charge is not conserved. Okay, charges can be created, positive and negative charge can be created from the energy. If you are aware, okay, positron and electron are pair, they can be created from energy, and that is possible. So total number of amount of charge of positive and negative can change, but overall charge should remain same. So that's why isolated is very, very important. It is not constant for any system, it is only constant for isolated system. It is not possible to create or destroy net charge, very important, net charge carried by isolated system, although the charge carrying particles may be created or destroyed. Charge carrying particles can be created or destroyed, but net charge will always be constant. Charges are quantities. So this is the main line that you have to mention. Okay, so charges are concerned for a total isolated system. So total charge of an isolated system will remain constant. If you write that line only, it is sufficient. Charges are quantized in nature. So free charges are always integral multiple, integral or integer multiple. What is the meaning of integral? Integral means it's a number represented by an integer. Integer means 0, 1, 2, 3, 4, plus minus, plus 1, minus 1, plus 2, minus 2. So plus minus 1, 0. Integer means, so integer is the set of numbers containing numbers. Okay, so that's how mathematicians write it, right? Plus minus 2 dot dot dot. So this is the set of numbers which represents integer. Integer is basically a set of numbers containing 0, plus minus 1, plus minus 2. Plus and minus both are possible. Okay, so all free charges are integral multiples of a basic unit of charge denoted by small e. So what is small e? Small is the charge of an electron, and that is given by 1.6 into 10 to the power of minus 19. Okay, and any other charge is basically given by n into e. Okay, n is an integer number, 0, plus minus 1, plus minus 2. So all charges can be represented like this. So you can take it with using an example. If you want to buy a packet of milk, you went to a shop and you asked, I want 1 packet of milk. Maybe the shop, but you actually required say only 50 ml of milk. If you ask the shopkeeper, I need only 50 ml of milk, will he give you a 50 ml of milk? He will say no, you have to buy the entire packet. If you require say 1 liter 50 ml, then you have to buy 2 packets of milk. Okay, if you require 2.5 liter milk, you have to buy 3 liters of milk. So basically, so there is a minimum quantity which is always integer multiple of this. Even if you require say something less, you have to go for the entire packet. So you can consider that charges always available in this packet, and the packets are basically E. Each packet is of value E. So everything will be always multiple of integer multiple of E. cannot be a fraction. So there was one intelligent question given in your model test paper, model question paper, where the charges are given as 2 times, 3 times and 4.5 times. So 4.5 times is not possible. 4.5 is not possible. Okay, 4.5 is not possible because 4.5 is not an integer, it is a fraction. So that charge is not possible. So any and every charge is not possible. Only when the charge is integer multiple of it is possible. Physics theory is easy and understandable, but I get stuck in numericals. How should I improve? Prema, you should practice more numericals, and theory is not always memorizing everything. Theory is also sometimes understanding. For example, this question. So how much charge is there in 1 coulomb? How many electrons are there in 1 coulomb charge? Okay, so that is something that you have to understand. That comes from this formula. Okay, so formula maybe you have understood, maybe you have understood the theory, but how to apply the formula is also something you have to see. So for example, let us see this question. It is from KCET 2024. A body has a charge of minus 3.2 microcoulomb. The number of excess electron it has. So you have to calculate the amount of excess electron. Now I am going to teach you a very unique trick that you can remember. Okay, so what is the trick that you have to remember? The trick is the 1 coulomb charge. 1 coulomb charge is basically, what is that? 1 by 1.6 into 10 to the power of minus 9 number of electrons. Okay, and you can remember this value. This will be very, very helpful. So 1 coulomb of charge means 6.625 into 10 to the power of 18 electrons. So if you are given 1 coulomb charge, how many electrons are there? That answer will be 6.625 into 10 to the power of 18. If you remember that, all other charges can be easily calculated. So this one value will change your life forever. So 1 coulomb charge means it is basically 6.625 into 10 to the power of 18 number of electrons. So that's how you can calculate any and every charge. So this is very, very handy for all those who are preparing for KCET. Maybe I don't think this level of question comes in JEE, but if you see some similar questions, you can answer that as well. Now 3.2 microcoulomb. Negative sign means extra electron, positive sign means less electron. Okay, so that is fine. You don't need to consider the sign. So 3.2 microcoulomb. 3.2 microcoulomb means what? 3.2 microcoulomb means 3.2 into 10 to the power of minus 6 coulomb. Right? So I already told you 1 coulomb equals to this much. So what you have to do, you have to just multiply. Remember, you are not allowed to use any calculator in the exam. You are not allowed to use any calculators in the exam. Into 10 to the power of minus 6 plus 18. Right? So minus 6 is there, plus 18 is coming from here. So it will be 3 6 18, 19.82, almost 20. Okay, so 20 into 10 to the power of 12. Right? Minus 6 plus 18, 12. So this will be 2 into 10 to the power of 13. So this approximation that this number is slightly more than 6, this number is 3.2, again more than 3, 6 are 18. So the closest integer value. So it is always very, very important for you to take the closest whole number. Okay, that is 3.2 into 6.6 will be very close to 20. They give the values like that only. So the correct answer is option C. Right? Yes, Pradyum is correct. Okay, not A. Anju. Sanjana, yes. Anjusri, I was back in solving numericals, but I got 60 marks other than numericals. What I want to do? Anjusri, you have to practice numericals. You have to understand what you are doing. Okay, so for example, this is a shortcut trick. If you want to calculate Q is equal to any, yes, that is also possible. Okay, 3.2 microcoulomb means equals to number of charges into E is number of charges into 1.6 into 10 to the power of minus 19. So N equals to 3.2 into 10 to the power of minus 6 divided by 1.6 into 10 to the power of minus 19. Now that is also possible. This is also okay. For this particular problem, it is okay. Okay, you will get 10 to the power 2 into 10 to the power of 13 directly. But in some cases, this is not super easy to calculate. And 10 to the power of minus 6, 10 to the power of minus 19, student gets confused. So that's why I recommend them to use this formula directly. This is a formula. Charge is given, multiply with 6.625 into 10 to the power of 18. And trust me, it will help you in many cases. Okay. This problem, it might be very easy for you, but in other cases, this calculation might save your time a lot. Okay, 10 to the power of 18 minus 6, let's write that. Now let's see one more question from KCET. A positively charged glass rod is brought near uncharged metal sphere, which is mounted in an insulated stand. If the glass rod is removed, the net charge on the metal sphere is 0, 1.6 into 10 to the power of minus 19 coulomb, positive charge, negative charge, and this is not more than 3 years old. 2023 this question came. After that 2023, 2024, 2025. So this is just a 3 years back this question came. So you might think what is the level of KCET? KCET is not super difficult if you understand the concept properly. Now tell me the answer for this question. Fundamental charge is charge of electron or proton. It is charge of electron because electron can be separated easily. That is why it is taken as charge of electron, but electron and proton both have same charge. So even if you say that charge of proton, no problem, but when it comes to definition, it is considered the charge of electron because charge of electron was the first thing that was measured. Okay, so J.J. Thomson. J.J. Thomson was the first person who actually measured E by m for electron. E by m is a fixed quantity for every particle. Okay, E is the charge of an electron, m is the mass, charge is to mass ratio, was first calculated for electrons. That's why electron is taken considered as fundamental, but otherwise electron and proton both have same. Technically it is not incorrect to say either proton or electron both are correct, but when it only comes to the strict definition, then it is electron. Okay, twice A. Nikhil, sir, I'm getting 135 of 118 KCET mock test and theory. Am I getting about 85%? Is it good marks? It is not bad. 135 at the beginning, it's not bad, but you should at least 135, you have to score at least 150 to get a good rank. Okay, 150 is considered a good rank along with your PUC result. So if you score around say 280, 290 and 150 in KCET, then your rank should be 500, below 500. Okay, so that is good rank. If you are scoring say 135 and if you are scoring around 270, then you should be around 2K to 3K rank. Okay, so that is how if you can improve by 15 marks more, your rank will be jumped drastically. That is one major important. Also PUC is also important. That's why yes, correct answer is 0. It's an isolated system. It is brought near, not touched. That means the charge will be 0 of the metal sphere. So this question came in KCET, right? Now let's see some question from your PU exam as well. PU2 preparatory exam and model papers. I have consolidated all the questions, previous year questions, model papers, question bank, and previous year model papers as well. So let's see one question. Which one of the following charges cannot exist in a body? So I have explained the theory. Now see if you are able to answer the question or not. 2E, 3E, 3.5E, minus 4e. Which one is not possible? Yes, A was correct for the last question. Sanjana is saying option C. Let's see someone else answering something different. Ananta is saying option C. Mylamp is also saying option 3C. Yes. So this charge is not possible. Why? Because this is not an integer number. 3.5 is not an integer number. So that's why 3.5 is not possible. So obviously, so as you see that the level of difficulty is slightly easier for PUC. Level of KCET is slightly tricky in some of the questions. But overall level of the difficulty in easier questions, it is exactly same as PUC. So KCET is easier level questions, which is about 20 to 30% of entire KCET paper. That is, you can expect 12 to 15 questions exactly same level as PUC. Okay, and remaining 35 to 40 to 45 questions will be difficult, not difficult, above PUC level. Now one more question. A body contains, this is very interesting question. Okay, if a body contains n1 protons and n2 electrons, then the net charge of the body. Think and answer. Do not answer randomly, just think it once and then answer. A body contains n1 protons and n2 electrons, then the net charge of the body is. So options are n1 plus n2e, n1 minus n2e, n1 minus n2, I think this will be n2 minus n1e, this will be n2 minus n1e, and then it will be n1 into n2 into e. So which one of them, which one of the answer is correct? Let's see who can answer. Yes, correct, Pradyum. You are absolutely correct. Wazir Ahmed is saying A, Pradyumni is saying 4B, Anjustri is saying A, Ananta is saying B. Okay, so either 1A or 1B, which one of them is correct? So now, so fight is between A and B. No one is considering C or D. Okay, let's see. So body has n1 protons. So what is the charge of a proton? Charge of a proton is plus E. So what is the total charge of n1 protons? Total charge of n1 protons is n1 into E, and this is positive. What is the charge of electron? How many electrons are there? N2 number of electrons are there. What is the charge of an electron? Electron is negative. So total charge is minus N2 into E. So remember, whenever you are considering electrons and protons together, you have to put the sign of the charges. So now if you take, both have same charges, E, so E got common and you get N1 minus N2 into E. So this is the total charge of the body. Total charge of the body is N1 minus N2 into E. In case electrons and protons are same, total charge becomes 0. If they are imbalanced, then either it will be positive or it will be negative, right? So if an object has n1 number of protons, you cannot simply add them, because simply adding is not correct. You have to consider the magnitude, the sign of the charge as well. So that's why you have to consider the sign for electron, which is negative. So always remember proton minus electron into E. N2 can be bigger than N1, then total charge will be negative. If N1 is bigger than N2, then charge will be positive. If they are equal, charge will be 0. Okay. Now let's move on to the next part. Before going on to the next part, if you want to practice more such questions, more practice is required for KCET, as well as all Comet K also we are going to launch very soon. But remember that if you are preparing for KCET, practicing mock test and the time management is very, very important. You will not get a lot of time to answer those 60 questions. You are having slightly more than 60 minutes, but I recommend practicing the KCET paper within 60 minutes, and that's why we are bringing you ABHYAS KCET 2026 test series, where you are going to get 35 KCET tests, and they are all KCET level papers, easy, difficult, medium, everything is mixed in one single paper. So 35 total KCET tests. Out of that, 4 tests are free. If you want, you can click on the description link given in the description and you can register yourself for the 4 free test paper. And if you want to purchase it, you can purchase it right away. Okay, chapter wise KCET PYQ, we are giving it absolutely free of cost with this year chapter wise KCET PYQs as a practice paper. Okay, so if you are practicing current electricity or electric charges and fields right now, you can go and check how many questions from the previous 10 years papers you are able to solve correctly. Real KCET exam pattern and timing, PCM as well as biology, those who have they can consider this. Biology is there also. If it is not there, you can ignore biology and you should consider PCM only. Okay, now let's move on. Coulomb's law, another very important concept for your PUC as well as your KCET exam. So the different type of questions comes from this concept. State and explain Coulomb's law. State Coulomb's law in mention Coulomb's law in vector form. These are the 2 most asked questions from this concept. Okay, so point charge. Before going into that, every time we hear point charge, point charge, point charge. What is the meaning of point charge? Actually, in practicality, no charge is point, right? They have some size, but then what is point charge? Nothing is exactly point like this, right? Point charge means it is not exactly like this. It can be bigger, but if the size of the charge object is smaller compared to the distance, okay, if the charge is smaller compared to the distance, then that charge is called point charge. Okay, point charge is nothing but in terms of distance. If distance is bigger than the size of the object, we can say this is a point charge. Okay, extended object means if the size is bigger, we cannot say it's a point charge in certain cases. But this chapter we are mostly focused on point charges. Point charge means distance is more compared to the size of the object. Okay, now what is the statement of Coulomb's law? The force acting between 2 point charges. Force acting between 2 point charges. It does not mention more than 2, only 2 charges are there. Okay, it is number 1, directly proportional to the product of the magnitude of the charges. Suppose this charge is Q1, this charge is Q2, then the force that is acting between them, it can be attractive, it can be repulsive, but the force is proportional to product of the charges. That means Q1 into Q2. Okay, inversely proportional to the square of the distance. So it is inversely proportional to the square of the distance, right? And this force actually acts along the line joining the charges. So this force cannot be in this direction or in this direction. It is always along the line joining the charges. So it can either be it's very important to understand, it can be either in this direction or in this direction. It will not be any other random direction. Okay, so if you join the charges, it can either act towards the other charge or away from the other charge. If the both charges are positive or negative, then it will be in this direction for same charges. For similar charges, opposite charges, it will be towards each other. Okay, this is for opposite, this is for same charges. Repulsive means away and attractive means towards each other. So that is also something that sometimes we ignore. The force along the line joining the 2 charges. Also, when it comes in terms of vector form, okay, so vector form, the diagram of the charge, this diagram is very important, and you also have to mention something which is called the unit vector. Okay, unit vector, you can show it any direction, does not matter. Okay, so it is force is given by 1 by 4 pi epsilon naught Q1 Q2 by R square into R cap. It can be negative as well. If it is negative here, then it will be away from. It is positive, then it will be towards. Okay, we have taken only value, so that's why it is R cap. Now remember, vector form, this R cap is compulsory, this diagram is compulsory, and the unit vector is also compulsory. There is one more diagram that you can draw, which is like this, q1, q2. Okay, so this is the origin, so that is in terms of origin, that is also possible. This is r1, okay, r1 vector, this is r2 vector, and this is this vector is r2 minus r1, and that is also possible. This is force F1, F2, okay, this is q1, q2. So F1 equals to K q1 q2 by r square into r2 minus r1 divided by r2 minus r1 modulus. Okay, this is also another form that you can write. Both answers are correct. Both answers are correct. But this is slightly tricky and difficult to remember. If you can write this form, you have to draw this diagram. If you are writing this form, you have to show this diagram. Diagram is compulsory. Without diagram, you will not get marks. Remember that. So if the vector form question comes in your PU board exam, the diagram is compulsory. Okay. Now here K equals to 1 by 4 pi epsilon naught is called Coulomb constant, and that value 9 into 10 to the power of 9 Newton meter square per Coulomb square is very important. Unit is important for PUC exam. In some cases you might be being asked what is the unit of Coulomb's constant, but otherwise 9 into 10 to the power of 9 is must to remember, okay, because it will be helpful for you to solve numerical question for your boards as well as for your KCET exam. Epsilon naught is called permittivity of free space, that is vacuum, which is 8.854 into 10 to the power of minus 12. If question comes based on this value, then remember this value will be provided in the question. In some cases it will be provided as 9 into 10 to the power of minus 12, or they might give you exact value. But if question comes based on this value, 99.99% the values will be provided in the question itself. Okay, at least for KCET it will be provided. In PUC exam also, if the question comes based on this value, they will provide the value, don't worry about it. The unit is important for your PUC. Coulomb square, Newton inverse, meter to the power minus 2. So this unit is important for your PUC exam. For medium dielectric, for medium of dielectric constant case only. So Coulomb, whenever he gave the formula, he assumed that there is nothing between these two charges, so free space. So that's why this is called free space. Free space means vacuum. Okay, free space. So that's why there is no other term involved in here. But if the medium is no longer free space, okay, this is a KCET level concept only. This question will not come in your board. Okay. So if this free space is no longer free, if you put a dielectric medium means a glass slab, okay, a resin or some water. Water can also be a dielectric medium. So if you put some dielectric medium between these two charges, completely filled, okay, this is not a JEE exam, so only complete filled part will come. So in that case, the effective distance is no longer r, it will be r into root k. Okay, so the same formula will still be applicable. Instead of r, in this formula you have to put r into root k. Everything else will be same. Okay, so if the question comes such as that, if you are putting a dielectric medium of say dielectric constant 4 between the charges, what will be the new force? New force will be the original force divided by 2, root 4. Okay, original force divided by the dielectric constant. So this is basically F by 2. So force reduces, force decreases if you insert a dielectric medium. Okay, so inserting a dielectric medium, the force decreases, and it happens by original force divided by root k. So that is one thing you can remember, or you can remember that when you are inserting the dielectric medium, the actual distance becomes r into root k. These two are very, very essential. Now next, let's see one question. This is from KCET 2022. 4 charges plus q plus 2q plus q and minus 2q are placed at the corners of a square ABCD respectively. The force on a unit positive charge kept at the center O is. So they have not asked you to calculate the value, they are asking you to calculate the direction. Only one value is given, which is given as 0. Other than that, along the diagonal AC, perpendicular to AD, along the diagonal BD. So they are basically asking you the direction. So in that case, you just need to draw the diagram. No calculation is required. So what are all the charges? Plus Q, you can take any order, but you should always follow a particular direction. Plus Q, plus 2Q, okay, plus Q again, and minus 2Q. And it is A, B, C, D. The order should be followed always, okay. Whenever this is about a square or rectangle, the order should always be followed. Okay, you can take ABCD. Some students start with ABCD. Okay, some students start with ABCD. That is also fine. So whatever you take, that is fine. Okay, we usually take in the anti-clockwise direction. If you want to take in the clockwise direction, that is also fine. But according to ABCD, the order should also be the same. Okay, now tell me, what is the force 0 at the center? So center is basically where these two diagonals meet. So what is either it can be 0, or you have to find the direction of the force. Scared that I won't be able to receive the 31 test papers even if I purchase. Why sub-school are not able to access for 4 free test papers? If you register, you have to register yourself. If you click on the link and register yourself, you can get it for, it will come in your mail. Okay, so make sure you are typing the correct mail. Once you type in the correct mail, and then only you will get the link to activate it. Okay, so once you are and you have to use our either you can use our app, or you can use our browser. It is available for browser as well. Okay, in case you are having some difficulty, you can mail us at the study@deekshalearning.com, study@deekshalearning.com, or also there is a phone number mentioned in this. You can call that as well. Okay, so if you want, I can give you okay, the phone number is not there, but you can mail at study make sure you are registering with a real email and a real phone number, otherwise it will not work. Okay, if you are giving some fake email, especially mobile numbers, what happens? No, if you are giving some fake mobile number, someone else had already used that mobile number, so that might not work. So make sure you are using your real mobile number. Okay, then only you will get the correct link, right? How to remember SI units and all? Is there any trick? MyLam. So SI unit, if you ask me, SI unit you can remember in 2 ways. First of all, for example, I am telling you one thing. You want to remember the SI unit of, say, epsilon, which is something tricky. Now, where does it come? So whenever you are seeing, so for example, the SI unit of gravitational constant or Coulomb's constant, Coulomb constant, free space permittivity or permeability. So whenever you are encountering a quantity, okay, try to relate them with known quantities. Okay, known quantities means try to relate them with most common quantities, which are, for example, mechanical quantities, force, momentum. Okay, those units are very easy to remember because we are studying it for a long time. We started studying about forces class 7th or 8th, and then we are continuing learning about them in 9th as well. Then we are studying in PU 1 as well. So that's why those quantities are easier to remember. Force unit is Newton, we all know, even we know that kg meter per second square, right? So those are something that we already know. In fact, those quantities I always recommend students to use them for dimensional analysis as well. So if you find a relation between the quantity and unknown quantity that you are trying to remember or trying to find the units, and the mechanical quantities, force, momentum, okay, work or energy. So if you can relate them, then your 99% work is done. For example, force is given by 1 by 4 pi epsilon naught q1 q2 by r square. Now what is unknown quantity over here? Epsilon naught. Now 4 pi is a constant, so you can ignore. So whenever you are trying to find the units, you can ignore the 4 pi. Now, so for here we can say that epsilon naught is basically 1 upon f q square by r square, right? In terms of units, right? In terms of units, simply q square by r square. Q into q1 into q2, Coulomb into Coulomb, right? So what is the unit of epsilon naught? So it will be Coulomb square. Q square is Coulomb square divided by r square means m to the power of minus 2 divided by force. Force unit is Newton, so minus 1. So this is how you can remember some quantities units. Any quantity you can try to relate it with the force or work or energy. Work and energy have same units, joules. So if you can relate them with this, you can find dimensions, you can find units, no difficulty, right? Sometimes it is it can be get tricky if you are finding it in terms of electric field. Electric field has two SI units. One is Newton per Coulomb, another one is volt per meter. Okay, so that's why volt per meter unit sometimes can be tricky if the option is given in terms of volt per meter. We have seen one such question in Comet K, but that was easily solvable. You have to check each and every unit and simplify them to find what is the relation. Okay, that is also possible. So for example, volt is nothing but if you multiply with charge, you get energy. Okay, volt is not, again, not a fundamental unit. Energy means joules. Okay, so volt is nothing but joules per Coulomb. Okay, that is also something you can remember. Joules means Newton into meter divided by Coulomb. Okay, so that sometimes this unit can sometimes be trickier because students forget that if you multiply potential and charge, you get energy, which is potential energy. Okay, volt is not joules, by the way, that's why it is referred to as a separate unit. So now tell me the answer for this question number 5. Someone answered option D, 5D. Anime, all chapters are covered, all important chapters will be covered. Okay, less important chapters we will try to cover in a separately, may not be live, but we will try to cover all the other important not important chapters as well. But we are starting off with all important high weighted chapters for PUC as well as KCET. So that is our target. Okay, so let's see. So here this is plus Q, this is plus Q. So the force on this plus Q will be along this direction, this plus Q will be along this direction. Now distances are same because it's a square, so net force due to this plus Q and this plus Q will cancel each other, so no force acting because of these two charges. So you can simply ignore these two charges. What about the other two charges? So this is a positive charge, so this will be away from. Positive charge, force is always away from. Okay, and this is a negative charge. Negative charge means it will be towards, because it's an attractive force, right? Attractive force means it will be towards the charge, right? So we can see that obviously these two forces are not cancelling each other, so not cancelling means 0 is not answer. Okay, so they are actually along the direction B to D. So it is along the diagonal BD. It is along the diagonal BD. Yes, 5D is correct. My lamp. Thank you. You are welcome, my lamp. So there are some, so that's why I'm saying that these lectures are going to be important, because I will try to cover as much basics as possible throughout the lecture. Now this question, I will not tell you the answer, but you have to answer this in the chat. A point charge A of plus 10 microcoulomb and another point charge of plus 20 microcoulomb are kept 1 meter apart in free space. The electrostatic force on A due to B is F1 and the electrostatic force on B due to A is F2. Then I will not tell you the answer. Okay, this will be left as blank. So that's why but you have to mention the answer in the chat below. Okay. So it is F1 equals to minus 2F2, F1 equals to minus F2, 2F1 is equal to minus F2, F1 equals to F2. So one of the answer is correct. Answer quickly. This is easy question. Question number 6. Quickly answer it. Point charge of A plus 10 microcoulomb, another point charge B of plus 20 microcoulomb are kept 1 meter apart in free space. The electrostatic force on A due to B is F1 and the electrostatic force on B due to A is F2. Then what is which relation is correct? Option B, sir. F1 and F2 both are magnitudes are same, so D. Parth is saying B, Mans is saying B. So Pradyum, magnitude, they are not asking you magnitudes. If there was something like this, then you could have said, okay, option D is correct. Okay, so yes, most of you answered it correctly. It is actually B, because magnitude will be same. So this also represents magnitude wise it is same, but the direction is opposite. Even if they are attractive, remember that even if they are attractive, the direction will be opposite. So if suppose this is plus Q, this is minus Q. Okay, they are attracting each other. So this is in this direction, this is in this direction. If they are repulsive, obviously they are this is plus Q, this is plus Q. So repulsive means obviously this is opposite direction. Attractive also it is opposite direction. Okay, individually forces are always equal and opposite. Newton's third law. Forces are equal and opposite. Okay, so if you consider one of the force is action, the other will be reaction. That's why F1 equals to minus F2. Now next, a point charge 1Q exerts a force F on another charge 2Q when placed at a fixed distance. If another point charge 3Q is brought near to 2Q, the force on 2Q due to 1Q increases, decreases, may increase or decrease, does not change. Very interesting question. Okay, Pradyum, I hope your doubt is cleared. Now answer this. This is a very interesting question, very fundamental question. Okay, so we had two charges. One charge was 1Q, means only Q, another one was 2Q. Okay, we have brought a third charge 3Q near to this charge. Okay, so what will happen to the force on 2Q due to the original charge Q? Not the net force, only the force on this due to this, not the net force. Remember, it is not talking about net force. That's why you have to read the question carefully. 7D. Mansi is saying 7D, Mylamp is saying 7D, Parth in between came answered B, Ananta is saying 7D. Okay, Parth now, Parth is saying 7B. So remember that if you have two charges, okay, the force between two charges is independent of any other third charges. Okay, force between two charges is always dependent only on one thing, that is the medium between the charges. If you change the medium, the force will change. If you change the distance, force will change. If you change the charges, magnitude of the charges, force will change, but it will not depend on any other third forces. Okay, so third party is not allowed in Coulomb's law. This force can change the net force. Net force will be different on 2q, but the force due to q on this charge will remain same. Okay, because the distance is same, the medium is same. If the same question was asked, if you have inserted a dielectric medium, force will definitely change. It is dependent on medium, but it is independent of third charges. So it does not change, it will remain same. It will remain same because the force between these two charges is independent of any other third charges, even if you put the charge between them. Even if you put this 3q charge between these 2 points, the force between these 2 charges will remain same. According to Coulomb's law, electric force F between 2 point charges separated by a distance small r varies as, easy question. Again, this question came in your one of your PUC exam, that's why I have taken it. Okay, so as you can see, the level of PUC MCQs are lot easier. Okay, so what is the answer? Obviously most of you have answered it. According to superposition, Anant, yes, Anant, actually yes, superposition principle also you can use. Actually superposition principle comes from Coulomb's law's basic principles. Okay, individually the force between 2 charges is constant, and superposition principle states that individually, if you want to find the net force, you have to consider any pair of charges. Okay, calculate the force between them and then vectorially add them. So in the magnitude wise, this force will remain same, direction wise it will remain same. Only thing is that because of this charge, the net force will change. Okay, but this force will not change. Any force between any 2 charges will be same as long as the medium is constant, the charges are constant, and the distance is constant. Okay. Question number 8, easy question, 8b. Yes, I will not waste too much time. This is a direct question from Coulomb's law. Now, electric field. From here onwards, the concept becomes slightly trickier. Okay, so in Coulomb's law, we had 2 charges. Force between these 2 charges was simple. Now, electric field comes slightly slowly. We are going towards some abstract things. Abstract thing means we will not be able to see them clearly. So electric field is the start of that part. Coulomb's force is easy to observe. Okay, we have done some experiments as well. 2 balloons, we rub it with some wool and they repel each other. Okay, so Coulomb's law is easier to observe. Electric field is not so obvious. Okay, you have to have some specific instruments and some sophisticated experiment to observe electric field in action. So electric field is something which comes into slowly we are going towards visualization. That means we are trying to think in our brain. The picture is not clearly visible, but we can see them in our brain. So that's why it is called visualization. Okay. Now, so we had 2 charges. Now, if we remove one of the charges in Coulomb's law and we have only 1 charge, is there any effect of this charge remains here? Any effect of this charge which is still there? Because when 2 charges are there, we are able to see repulsion, attraction, like that. Now only 1 charge is there, so we are not able to see any attraction or repulsion. But so that's why people started asking, if 1 charge is removed, that means everything is finished or something is left. So from there onwards, we came into the idea of electric field. Electric field means the influence of this charge at a distance. Influence of a charge at a distance is called electric field. Okay, it can be represented using diagrams. It also has a formula. Now, so theoretically the range is r equals to slightly more than 0 till infinity. Okay, now remember that Coulomb's law, concept of electric field, they are not exactly valid at the location of the charge. So there was one question came in I think midterm exam. drawbacks of Coulomb's law. Coulomb's law is not applicable to extended charges. Okay, it is only applicable to point charges. Secondly, it does not applicable at the location of the charges. Okay, so if you consider the location, exact location of the charge, Coulomb's law concept of electric field is not applicable. Okay, so it has to be separated by some distance, then only Coulomb's law is applicable. So except this, so this is slightly distance slightly greater than 0. Okay, so this is exactly r equals to 0. Okay, so r slightly greater than 0 till infinity theoretically. Okay, till infinity the electric field exists. Electric field, but the value of electric field decreases drastically with distance. Again, electric field normally for a point charge is given by this formula, 1 by 4 pi epsilon naught q upon r square r cap. Okay, so electric field due to a point charge is given by 1 by 4 pi epsilon naught q by r square into r cap. It is also a vector quantity. If the charge is positive, electric field is pointing outward. If the charge is negative, electric field is pointing towards the charge. This is for positive charge. This is for negative charge. Now, if you say, sir, how do I remember what is positive, what is negative? So, for that, you have to have a best friend. I always say that unit positive test charge is your best friend. So, whenever you have a doubt, you put a unit positive test charge at the point, and if it is experiencing a force away, then it will be away from. If it is experiencing a force towards the charge, it is attractive, that means it is towards. Okay. So, in case of electric field, remember that a trick when solving numerical questions, that whenever you are solving electric field, even though it's a vector quantity, first of all, for PUC level, vector sign is not important, not super important. In some problems, they might ask you what is the direction, that I will discuss later on. But otherwise, direction is not super important, and the sign of the charge is not important. Okay, so electric field, whenever you are calculating electric field, remember that the only formula that you need to know, 1 by 4 pi epsilon naught q by r square, that is the only formula you need to remember. Now, if I say, okay, sir, you are saying the direction is not, the sign of the charge is not important, but in many cases we are asked to find electric field due to multiple charges. So, what should we do for that? So, in that case, what you have to do, you have to calculate the direction, you have to find the direction. Okay, positive or negative. Based on that, you have to say whether they are acting in same direction, opposite direction, perpendicular direction. These are the three directions that you will face. Okay, in JEE maybe you will see some other angles as well, but in PUC and KCET level questions you will see these three directions. Okay, same direction, opposite direction, or perpendicular direction. Okay, if they are in the same direction, electric field gets added. Now, no matter if the charge is positive or negative, okay, if the direction of electric field is same, they gets added. That's why I always mention, whenever you are calculating electric field, do not put the sign of the charge. Direction is more important than sign of the charge. So, if you put, so say one charge is positive, one charge is negative, but the electric field is in the same direction. So, what you eventually get, if you put the sign, you will get 0 answer. But because the forces are in the same direction, electric field are in the same direction, actually it should be added up. Okay, so direction is important than sign of the charge. Sign of the charge is not important when calculating electric field. Direction is important. Okay, for positive charge it is away from, for negative charge it is towards. Okay, in case of perpendicular electric field, how to do that? Okay, in case of most of the cases you will find both the components are equal. So, if suppose this is A, this is B, the angle is 90 degrees. So, what is the resultant of these two vectors? Very simple, Pythagoras theorem. The resultant is given by, the resultant electric field is given by square root of A square plus B square. Okay, so this is also quite possible in case of KCET and board exam as well. Okay, in case of numerical questions, there are times when you find the resultant vectors, you have to use this formula, vector addition, vector addition. This is nothing but vector addition, so you have to add them vectorially. Perpendicular case, a square plus b square square root. Okay, so these are the important basic things that you have to remember. The electric field due to a charge q at a point in space may be defined as the force that a unit positive charge would experience if it is placed at that point. So if you place a unit positive test charge at a point, it will experience a force, and that force is given by this electric field. Now till this point we still have a charge. From next page onwards, you will even see this charge is also vanished. So we will only have left with this electric field. So we started with Coulomb's law where two charges are there, then one charge is removed, we came into the concept of electric field. Now onwards, only electric field will be given and no charge will be there. So that's why I am saying that we are slowly transiting from known things to unknown. Okay, so we are moving from all the charges are known to we are moving onwards for visualized things. That's why the things get difficult from here on. Okay, but if you are listening up to this point, if you stay till the end, definitely I will clear a lot of doubts that you might still have in your mind. Okay, alternatively, if a charge q is kept inside the electric field E, so that's what I am saying, only electric field is given now, no external charges are present, only electric field is known. Okay, you keep a single charge inside that electric field, then this electric field will apply a force in this charge. Okay, so this electric field will apply a force on this charge, and that force is given by Q into E. So Q into E is electric force. Now what is the unit of electric field? Unit of electric field is Newton per Coulomb. Okay, so from here also you can calculate, force is Newton, charge is Coulomb, so E will be F by Q, so that is Newton per Coulomb. When a positive charge is kept inside an external electric field, it experiences a force in the direction of electric field. So if the electric field is given, if you keep a positive charge, it experiences a force in the direction of electric field. Now no source of charge is there. Okay, this charge is called source charge. This is called source charge. Now source charge is not known. In many cases source charge is actually not known. For example, electric field due to a current carrying wire. The electric field is not very simple, it is complicated. So source charge is not known. Electric field inside a solenoid, or electric field due to something which is moving. So in those cases, electric field is more important than source charge. But if you keep an external charge, okay, if you put a charge inside that electric field, it will experience as a force. If it is positive, it will experience a force in the direction of the charge, electric field. If the charge is negative, it experiences a force in the opposite direction of electric field. Okay, so an electron will move in the opposite direction, a proton will move in the direction of electric field. Okay, so this is important and easy to remember. Does it for NCERT? I don't understand your question, Sumed V. You are trying to write control V. Sumedha, what is your question? You are only asking does it for NCERT. I don't understand your point, bro. If you want to ask me something, please ask it clearly. That language, does it for NCERT, I don't get it. So when a negative charge is kept inside external electric field, it experiences a force in the opposite direction of the electric field. Okay, clear? If you have any doubt, mention in the comment. Okay, next question. A charged particle of mass small m and charge Q is released from rest in an uniform electric field E. Neglecting the effect of gravity, the kinetic energy of the charged particle after t seconds. So this is a mixed concept question where the concept is not exactly from this chapter, but obviously you have to know the concept of this chapter as well as one concept from your PU1, that is the concept of kinetic energy, to solve this question. Okay, so not difficult question, but we say in our language, you say mixed concept question. Okay, it considered to be medium to hard question. So charged particle of mass small m and charge Q is released from rest in an uniform electric field. Neglecting the effect of gravity, so gravity you do not need to consider. What is the kinetic energy? How can you calculate? Electric field is produced by a charge. Ananta is saying yes, it is produced by a charge. It can be produced by a static charge, it can be produced by moving charge, it can be produced by changing magnetic field as well. Okay, so source charge, if I say it is a source charge is not always well defined. Okay, somewhere some cases somewhere there is a charge involved, but that charge may be known, may be unknown. Okay, the type of the charge may be known, may be unknown, but electric field is more prominent. Actually, electric field is more fundamental than charge. Okay, you will see that later on Gauss's law. Even Gauss's law is more fundamental than Coulomb's law, because Coulomb's law can be derived from Gauss's law. Okay, so Gauss's law considered to be is considered as more important, more fundamental than Coulomb's law, even though Gauss's law came later after Coulomb's law. Okay, so there are some things which are little not so super easy. Okay, even charges, if I say, if you go to in the quantum mechanics, electrons are not the only particles that carry charges. There are few other things that can carry charges. Okay, so that's why it is not super easy. So field is lot easier than understanding forces. Okay, so that's why we are slowly moving away from Coulomb's law towards field. Okay, if you study physics in higher classes, you will realize it more why field is more important than forces. Yes, we needed a bridge from charges to field. That's why we started with Coulomb's law, which deals with charges, and then slowly we move towards fields. Okay. Okay, now answer this question. What is the answer of this question? So a charged particle of mass m and q is released from rest in an uniform electric field E. So what is the force that is acting on this charge? Force acting on this charge is q into E. So force acting on this charge is q into E. So if there is acting a force, then definitely it will be another form, that is force equals to ma, further equals to ma. Okay, so from there we can say that we can calculate the acceleration. We can calculate the acceleration. So acceleration is given by q into E divided by m. Right, so if we can calculate acceleration, we can also calculate the velocity. Velocity is given by u plus at. Right, here they have asked about after t seconds, and it is initially was at rest, it was released, that means u equals to 0. So velocity equals to q into E into t divided by m. So velocity is known. Now what is kinetic energy? Kinetic energy is very simple, half m v square. Okay, so half m into q square E square t square divided by m square. One of the m will cancel and we get q square E square t square by 2m. So if you know how to solve, it is easy. If you don't know, it can be very, very tricky and difficult. So correct answer is E square q square t square divided by 2m. Okay. but V how to find? Pradyum, yes, you are almost correct. So you forgot the most basic formula, V is equal to U plus AT. Okay, V is equal to U plus AT, and because it is mentioned charge particle of mass M and charge Q released from means whenever you are releasing something, that means initial velocity is 0. It is getting accelerated because of the electric field. Okay, so because of the electric field is present, the charge will be accelerated, and that acceleration we can calculate, and then from the motion, equation of motion, you can even calculate the velocity. Okay, so V equals to U plus AT, U is 0, A we have calculated, that means velocity is Q in E into T by M. Now simple kinetic energy formula, if you put it, you can answer. So this is this came in 2022. In my opinion, this is not actually a difficult question, but that year those who appeared for the first time, they might find this question slightly tricky and difficult, but obviously toppers will be able to answer, but the medium level question students might find it little difficult, but that's why I always ask you to practice little bit, okay, and try to understand the interrelationship between different quantities, which is very, very important. Now another question, this is easy question for PUC. Placed in an electric field experiences a force in the direction opposite to the electric field, electron, positive charge, neutron, proton. Answer this question quickly. Let me have a sip of water. Okay. 10A. Yes. So dash placed in an electric field experiences a force in the direction opposite. Opposite direction means it's a negative charge. Negative charge means definitely it's an electron. Okay. What next? Electric field lines, properties of electric field lines itself. This might come as a question in your PUC, and this is one of the most asked question. 3 properties of electric field lines, 2 properties of electric field lines. Both questions are possible, as well as these concepts can be part of your MCQ questions as well. Okay, so this is one of the most important concept along with Coulomb's law and Gauss's law. This is also a very, very important concept because it has came multiple times in KCET as well as in your PUC exam. PUC exam the questions are direct, okay, 3 properties, 2 properties, or MCQ. In KCET it will come only MCQ. Field lines start from positive charges and end at negative charges. If there is a single charge, they may start or end at infinity. So electric field lines is the visual representation of electric field. Okay, so electric field, as I mentioned, is not super easy to understand, so that's why we have brought in a new tool for us, and that tool is basically electric field lines. Suppose we have a charge, okay, single charge. Okay, so again, whenever we want to understand electric field, we have to use the charge, but then we will remove the charge and we go to only field. Okay, so that's our strategy, okay, always. So charge is easy to understand. So from a positive charge, it can go to a negative charge. If the charge are positive, it can go like this. It will always start at positive, it will always go to negative. The reverse is not possible. Negative to positive is not possible. It will only unidirectional. If a charge is single positive charge, electric field will be only away. Okay, it will go towards infinity. As I mentioned, theoretical ranges are slightly greater than 0 till infinity. And if the charge is negative, again electric field lines will come from infinity towards the charge. Okay, now again we have received question, draw the electric field lines for a positive charge for an electric dipole. Okay, electric dipole is like this. Okay, electric field lines coming like this, it is going like this, and it is coming like this. Okay, electric field lines due to a dipole looks like this. electric field lines into individual charges looks like this. So these diagrams are also important. Remember that. In a charge-free region, electric field lines can be taken to be continuous curves without any break. So if there is no other charges present, electric field lines will be continuous. It will be a straight line or curved line without any break. Any break means electric field lines are not like this. Okay, electric field lines are not like this. Some people draw it like that, but this is not correct. If there is no charges, it will be a continuous line. It will be a continuous line. Okay, no breaks between the line. Okay, clear? This is the second property. Third property, a tangent drawn at any point on the electric field line gives the direction of the electric field at that point. So if you have an electric field line, if you want to know the electric field exactly at this point, okay, you have to draw a tangent. That tangent will give you the direction of electric field at that particular point. If you move on, the direction might change. Okay, so direction might change with position, but at any position, if you draw the tangent, you will get the exact direction of electric field at that particular point. Two field lines can never cross each other. If they did, the field at the point of intersection will not have a unique direction, which is absurd. So if two electric field lines cross, suppose two electric field lines, one is going in this direction, another one is going in this direction. So at the point of intersection, we would have two electric field, which is not possible. A vector quantity can have only one direction at each and every point. It cannot have multiple direction. That is called unique direction property of a vector quantity. It is slightly deeper concept. Okay, but if you see that at this point a vector quantity, same quantity, having two different direction, which is not possible by definition. Okay, so that's why two electric field lines can never cross. Actually, what happens if they were to cross? Suppose we have already one existing electric field, another existing electric field appears over here, then what will happen? The electric field lines will rearrange. Okay, they will rearrange such a way that they do not intersect. Okay, basically you will get the net electric field. Okay, so because you will get the net electric field, theoretically you will not be able to merge two electric field lines at same point. You will get the resultant electric field line. Electrostatic field lines do not form any closed loop. Closed loop means if starting point and ending point are same, then it is called a closed loop. So it is going from A to B and then it is coming back to B to A. So if this is called closed loop. Electric field lines are open, they do not form closed loop. Magnetic field lines are closed loops. Electric field line in free space decreases as we move in the direction of electric field lines and vice versa. Based on this also we have seen some questions. So suppose an electric field is given like this. If you are moving in the direction of electric field lines, so this is EA, this is EB. Okay, some electric field is represented like this. So remember, if you are moving in the direction of electric field, then this is lesser than this one. So EB is greater than EA. So when you are moving in the direction of electric field, the electric field decreases because we are going towards infinity. Towards infinity means electric field is obviously reducing, right? So this represents either infinity or generally it represents the direction where electric field lines, the electric field value is decreasing. Okay. Next we will discuss about electric dipole. Sir, more KCET PYQs. Yes, Trupti, we are solving. This is Varija Salian, your old student in the YouTube. Yes, Varija, I remembered you. Last year you are one of our favorite students. All the teachers were asking you. Yashas Salian. Okay, your name is changed now. Okay, Varija, we all miss you. Come visit us sometime from time to time. And let me know what you are doing right now. Let's see. Two equal and opposite charges separated by a small distance is known as electric dipole. Okay. Two equal and opposite charges separated by a small distance is called electric dipole. For example, plus q minus q. So charges are equal, magnitude has to be same, distance has to be small. It cannot be, if you say that distance is centimeter or in meters, it is not a dipole. Dipole means it has to be micrometer, at least millimeter, micrometer or nanometer is more accurate, okay, but it should not be centimeter, okay. For example, HCl, okay, we all know in chemistry that hydrogen gives one electron, chlorine gives one electron, and they form one bond. But this bond is not like that. The chlorine is more has higher electron affinity, so it will attract the electron pair towards it, okay, and because of that the hydrogen is almost have lost this electron and chlorine has almost gained this electron, okay, even though they are sharing, okay, sharing has some rules, okay, we are sharing but it is with me. Chlorine is saying we are sharing one electron each, but the electron will stay with me, okay. So chlorine you can consider is like some big brother. When you are sharing something with your big brother, you will say, okay, we will share, but the cards after playing the cards will stay with me. So like that, okay. So hydrogen becomes slightly positive, chlorine becomes slightly negative, and these two this atom, whenever this molecule is formed, actually they are already formed with a dipole moment, okay. Dipole moment we will see in a while. This is an example of electric dipole in real life, okay. So dipole moment is very important quantity for a dipole. Electric dipole moment is the product of magnitude of the charges and the distance between them. This is a vector quantity, so charge into distance. So, and what is the direction? Direction is unit vector from negative to positive charge represents the direction of the dipole. So the direction of dipole is from negative towards positive, from negative towards positive, okay, not other way around. Normally electric field is opposite, for positive it is away from, for negative it is towards, but for electric dipole the direction of dipole moment is opposite to that. So don't get confused with chemistry. Chemistry is slightly different direction. Physics, it is from negative charge towards positive charge, okay, and magnitude wise q into 2a is the dipole moment. The unit of dipole moment is Coulomb meter and its dimension is lat, okay, lat, okay. So lat is basically in dimension of dipole moment. Now the field due to electric dipole points on the axis. Do you want me to derive this relation? If you want, I can do that. Yes, study for your success, the notes will be provided. I am pursuing BTech in robotics and artificial intelligence. Congratulations. Which college? Don't forget to mention that as well. Hello Gautam. No, you don't want me to derive it. Okay, if you don't want it, I will not do it. The notes will be provided after the lecture is over. You have to be present in our WhatsApp channel to get the notes, okay. If you want, I will do the derivation. Okay, so if you don't want, I will not do it. It is common derivation. So answer, the derivation is axial is given by 1 by 4 pi epsilon naught 2p by r cube, okay. Obviously if you want to do the derivation, obviously I have done it multiple times, but you should practice the derivation for your PUC exam. For KCET exam, this formula is sufficient. For PUC exam, this is a very, very important derivation that might come in your board exam. It came in the past, it might come in future as well, okay. So point on the axis. This is how you have to remember the diagram. The distances are always measured from the center of the dipole, okay, and this is where r is greater than the distance between the dipole, okay, half distance between the dipole. Obviously the distance between the dipole is smaller, So any distance along the axis, and remember it is if this is positive, this is negative, then it is in this direction. Okay, it is in the direction of the dipole moment. Okay, direction of the dipole moment and axial electric field, they are in the same direction. Dipole moment is also in this direction and axial electric field is also in this direction. Okay, they are in the same direction. Next is okay, Pradyum is saying equatorial derivation. Okay, equatorial derivation is next for points on the equatorial plane. So here we have two charges, say this is positive Q, this is negative Q. Obviously your request is my command, so I will try to do as much as is possible to help you. This is plus Q, this is minus Q, and we are trying to find the electric field at this particular point. So this is our point of observation P. Now electric field due to a positive charge, what is the direction? As I mentioned, sign of the charge is not important, direction is important. The direction is obviously positive charge, it will always be away from. So this is the electric field positive, right? What about the negative charge? Negative charge attracts thing towards it, so electric field will always, obviously it will be towards the negative charge. This is E minus. Okay, so what is the distance between these 2 points? The distance between these 2 points, say x. Say x. What is the distance between these 2 points? So equatorial plane means it is basically dividing it into 2 halves. So if this distance is x, this will also be x. Right? This is an isosceles triangle. So isosceles triangle means these 2 arms must be equal, not this arm. Okay, this is a separate arm. These 2 arms must be same. So if this is x, this will also be x. Now what is the value of x? So you have to apply Pythagoras theorem. This is a, this distance is given small r, so x will be simply square root of a square plus r square. We will keep it in mind, we will put that later on, not yet. So x is known. Now what? Now we will say what is the value of this E plus and E minus. So if you see that this is plus Q, this is minus Q, so magnitude wise both charges are same, distances are same, so magnitude wise E plus must be equals to E minus, right? Magnitude wise these 2 electric field must be same, right? Why? Charges are same magnitude wise, distances are also same. So if distances are same, charges are same, electric field is equal to kq by r square. So definitely magnitude will be same, and we will denote this magnitude by another value, say E, and we will say C. Okay, now what is this E? This is only magnitude. So we can write this as kq upon x square, right? kq upon x square. Right? K is Coulomb's constant, Q is the charge, magnitude of charge, x is the distance. So now we found these 2 electric fields. Now we have to add them. How we can add 2 vectors? Either you know the angle between them, and add them, or, and that formula is little longer obviously, or there is one more method which is basically divide them into components and add them. Component method we are going to use for this particular case. So what we are going to do, we have to take 2 components. This is the x direction, right? This is the y direction, right? X axis, y axis. So same thing we are doing it over here as well. Okay, so this is x direction, this is y direction. Now for x direction, if you see, if this angle is theta, this is extended angle, so this angle will also be theta. Now again, if this angle is theta, this is an isosceles triangle, so if this angle is theta, this angle will also be theta, right? So if this angle is theta, this and this are alternate angle, so this will also be theta. Okay, alternate angles are also equal, and this is same angle, similar angle, so this will also be equal, right? So both these 2 angles are same. So if you take x component of this will be along this, x component of this will also be along this direction. Okay, y component of the positive one will be in the top side, y component of the negative one will be the bottom side, right? You have to basically take the projection. So projections are opposite direction. Now because these angles are same, because the magnitudes are same, so y components will cancel each other. So y components will cancel. Okay, so only thing that we are left with these two x components that we have. So the net electric field is basically the x component. So net electric field is basically x positive plus x negative. Okay, for positive charge x positive, for negative charge x negative, both are same by the way, and both are basically what? Both are the x component of this, so it will be 2 into E x component. Now how to calculate the x component? What is x component? X component, if you know a vector, if you know an angle, then what is the projection? Projection is basically, if this is the vector, this is the angle, then it is E cos theta, right? Adjacent angle. So adjacent angle, this is E cos theta. So basically it is nothing but 2 into E into cos theta. That's it. Okay, so you have to take twice of the electric field vectors. So 2E cos theta. So 2 into E value we already know, KQ upon x square, into cos theta. Now theta, we cannot leave it in cos theta, we have to put the value of theta, cos theta. So what is cos theta over here? Cos is, some people have curly brown hair turned permanently black. So curly brown hair. So it will be base by hypotenuse. So what is base? Base for this theta is this, that is A, and hypotenuse is this one, so this is x. So we get it is A upon x. Okay, clear? Now put the it is time for us to consolidate everything. So K into Q into 2 into A divided by x cube, right? Now what? So now we get Q into 2A. What is Q into 2A? Q into 2A is the dipole moment. So net electric field is K into dipole moment divided by x cube. Now it's time for us to put the value of x over here. So E net equals to K into P divided by A square plus x square, A square plus R square, and it will be 3 by 2. Okay, there is a square root over here, there is a cube over here, so it will be 3 by 2. Now we have to approximate that R is very greater than A. That means R square will be much more than A square. So for example, if A is 1, R is 2, A square is still 1, R square will be 4. So square means if you are squaring a larger number, the square increases. That means definitely A square will be much smaller compared to R square. So we can ignore this term and we can say that a net electric field equals to K into P divided by R square to the power 3 by 2. So this 2 cancels and we get net electric field equals to 1 by 4 pi epsilon naught P by R cube. Now if you see the direction of this net electric field, this is along this direction. What is the direction of the dipole moment? Dipole moment is from negative to positive. So this is the direction of dipole moment. This is the net electric field. So when you consider the vector form, then it becomes the net equatorial plane electric field is equals to minus 1 by 4 pi epsilon naught p vector upon r cube. Okay, the negative sign represents the direction of electric field and the dipole moment are in the opposite direction. If you are not using the vector sign, positive is okay, but if this derivation comes, you have to, at the end you have to show the negative value as well. Okay, you have to show the negative value as well, right? And negative value will come with the vector sign. Without vector sign, negative value has no meaning. Clear? Any doubt? Anand, happy birthday. Thank you for watching. How many marks you were perceived in KCET and also in theory? I don't get your question. Negative value be started from the beginning, not required. Negative value from the beginning is not required. At the end you have to mention that the direction of net electric field and the dipole moment are in opposite direction. That's why when you are writing in vector form, it will be negative. You don't need to put the negative sign from the beginning. Actually it will not come from the beginning as well. Okay, so if you only after you establish this term is dipole moment, then only this concept comes. Okay, and only after doing this you have to show the negative sign at the end, saying that vectorially the vectors are of opposite direction. That's why it is negative. Okay, you don't need to show the negative sign from the beginning. Dipole in an uniform external field. This derivation is very essential and important. Okay, torque acting on a dipole kept in an external electric field, tau equals to P cross E, tau equals to PE sin theta. Formula is important for your KCET as well. In uniform electric field, net force is 0 but torque is non-zero. Okay, so in uniform electric field, net force is 0. Net force means, so this is positive, suppose this is positive, this is negative, positive will experience a force in this direction, negative will experience a force in this direction. They are equal and opposite, so net force will be 0. But because they are acting at two different points, okay, the net torque is not 0. Torque is not 0. Uniform electric field means electric field is constant. Electric field is constant everywhere in this region, then it is called uniform electric field. So you have to remember, uniform electric field means constant electric field in a region, that is uniform. Now non-uniform electric field means the electric field is not constant. Suppose electric field is 10 over here, it is say 8 over here. So if electric field values are not same, then it is called non-uniform electric field. So non-uniform electric field means this charge will experience more force compared to this charge. That means obviously because the point of action is different, torque will obviously act as well as the net force will also act. So the dipole will move in the direction where force is more. Okay, so for non-uniform electric field, both force and torque are not 0. Okay, uniform electric field, force is 0, torque is not 0. Non-uniform electric field, both force and torque are not 0. Okay, torque can be 0 when theta is 0 degrees or at 180 degrees. So if theta is 0 or 180 degrees, sin theta becomes 0, and that's why torque can be 0 only when at these two angles. In general, when the angle is not mentioned, torque is not 0. Now you do want me to derive this easy derivation. I watch your class in different phone. Okay. Your name is Monica. Akshata N, if you are not able to hear me, just check your mobile audio device volume, because I can see my monitor showing me that my voice is getting recorded. Also, if anyone else is facing this difficulty, let me know. My lamp is saying, sir, question bank series still there or completed? Question bank series is completed. As many chapters were possible, we have covered it in our question bank series. Right now we are not continuing with the remaining chapters, but if you want, please mention in the comment below. Based, if we get say 100 comments in the comment, then definitely we will give you at least recorded format of those remaining lectures. Okay, but for now we are not doing, but all the important chapters we have covered, and all the important typical MCQs also we have covered. But right now we are not continuing with remaining chapters. If you want them, mention in the comment below, or you can check our Brahmastra series, where MCQs, 2-3 marker question, 5 marker questions are all covered in the same video. That is also very, very essential. Ananta is saying torque and force. Non-uniform produce both. Yes, non-uniform produce both. Now, do you want me to derive the formula for this one, tau equals to P cross E? Otherwise, I will continue to the next. Sanjana is saying thank you, welcome. Okay. No sir, I am not continuing. Easy derivation, solve some questions. Question solution time. An electric dipole with dipole moment 4 into 10 to the power of minus 9 Coulomb meter. So remember, this is not centimeter, okay, this is Coulomb meter. Centimeter is where C is small, M is also small. If C is capital, M is small, it is Coulomb meter. Last year in your board exam, there was one problem happened. Okay, they have given a unit which was microcoulomb meter, okay, and microcoulomb per meter, I think, and they have taken it micro and they written it like this. So even though this does not make any sense, what is the unit? It was given as a charge density, and students approved, sir, this question is wrong, but they did not give any bonus mark for this question. It was understood that because it's a charge density, it has to be microcoulomb per meter, but they gave one option, either you solve it as microcoulomb per meter or microcoulomb per centimeter. Both answered they have considered, but they have not considered if you say that I want to get a bonus point. Okay, now C and M, if C is capital, remember this is Coulomb. Okay, this is Coulomb, this is not centimeter. Okay, is aligned at 30 degrees with the direction of uniform electric field of magnitude 5 into 10 to the power of 4 Newton per Coulomb. The magnitude of the torque acting on this dipole. So what is the magnitude of the torque? Very simple, PE sin theta. So this type of simple direct formula based questions also come in KCET. Electric dipole moment is given 4 into 10 to the power of minus 9. Electric field is given 5 into 10 to the power of 4. Okay, and angle is given 30 degrees, so sin 30. Okay, so 5 4s are 20 into 10 to the power of minus 5, and sin 30 is half, so we get 10 into 10 to the power of minus 5 or 10 to the power of minus 4. Okay, so it will be 10 to the power of minus 4 Newton meter. Option B. Yes, B. Yes, Pradyum, you are correct. Sanjana is saying many more questions for KCET. Sanjana, we have solved many questions in our previous PYQs. I will be solving some important KCET questions which are not KCET PYQs at the end of this lecture. Just wait for a few more minutes. I am almost at the last concept, Gauss law. Once that is done, we will be solving numericals as well as some KCET level question which are not PYQs. Okay, so I will be solving those type of questions as well. So total charge of an electric dipole is easy question. Total charge of an electric dipole, and this is a PYQ. This is a PYQ question from previous year paper, PUC paper. Total charge of an electric dipole. And if you want to watch some other videos, I would like to recommend you check our top 30 that was going on few days back. We released few questions, but obviously students did not like it. We did not get as many views and likes that we are wanted from there. So you can check that video. That is a very secret hidden videos where we have solved a lot many PYQs, or you can check our previous year question series from Sankalp where we have solved a lot many PYQs. But don't worry, this is just the beginning. Okay, this is where we are learning concepts and how to solve questions. Next one, when we are done with this series, okay, it will not be over. We will continue with more question practice. So don't worry, we will be solving lot more questions, PYQs, not PYQs, KCET level question, PUC level questions, everything will be done here. Okay, so total charge of an electric dipole is what? Sir, what about Brahmastra series? Only 8 chapter PDFs are provided. Study for your success. You can check. There are 2 chapters which are combined, and if there are any chapters missing from physics, I will check and I will update that as well. Okay, so this is 0. Okay, I think there are in 2 cases 2 chapters are combined, so you will get 12 PDFs. If there are some PDFs missing, one chapter went live last week, so that chapter I will add, and if any other chapter are missing, I will try to add them. Okay, total charge of an electric dipole is 0 plus Q minus Q. So total charge 0. When a free electric dipole is placed in a non-uniform electric field, the dipole will experience both force and torque, only force and no torque, only torque but no force, neither torque nor force. Again, I have discussed this question. I will not tell you the answer, so you can answer this in the chat. Obviously, I will not tell the answer. I have discussed it. Yes, correct. Ananta is correct. I think your name, you said your name is Monica, right? Monica, yes, it is correct. Now let's move on. So I will not give you too much time, easy question. So I am not, if you wish, you can pause here and answer it. If you want to read it and answer, otherwise I will move forward. Now continuous charge distribution. Charge distributions are 3 different types of charge distribution. For PUC, all the units and dimensions are important. For KCET, only dimensions are important. Okay, for PUC, both units and dimensions are important. KCET, dimensions are important. Line charge density means charge per unit length. Okay, you take 1 meter length. Okay, it's just a line. Line means a wire kind of thing. Okay, if it is charged, you take 1 meter of this length, you measure the total amount of charge, that is called charge density. The symbol for that is lambda. Its unit is Coulomb per meter. Dimension is L to the power of -1 A into T. Surface charge density. Surface means there is a surface area. Charge is only on the surface. Okay, that is denoted by this symbol sigma. Unit is Coulomb per meter square, and dimension is L to the power of -2 A into T. Volume charge density. Volume charge density means again the same thing, but its charge is located everywhere inside the volume. It's a solid object, and charge is everywhere inside the volume. Its symbol is rho, and unit is Coulomb per meter cube. Dimension is L to the power of -3 A into T. Based on this also, we have received many questions in PUC. And in KCET, the dimension might be asked, so remember the dimensions as well. Now, electric flux and Gauss's law. So what is electric flux? Very simple. Electric field is passing through an area, okay, surface area. Then electric flux is defined by the dot product of electric field vector and area vector. Area vector means, area vector is considered, suppose this is a area, then area vector is basically a perpendicular vector which is perpendicular to the area. Okay, and generally it is taken in the direction of the electric field. The area vector can be in this side also, in this side also, but convention is it always in the direction of electric field. Okay, if the angle is not 0, then it is given by Es cos theta. Angle may not be 0, but we always take it as Es cos theta. Angle will be provided, and we will always take the acute angle, not the obtuse angle. Okay. Statement. Now what is Gauss's law states about? Electric flux through a closed surface. This is an open surface. Closed surface means you are always boxed. Okay, it can be a box, it can be a sphere. If it is a closed surface means starting and ending will be same. Okay, for example, a football is a closed surface. Okay, Amazon box, when it came to your home with full packed and everything sealed, it's a closed system. Okay, closed surface. These are example of closed system. Electric flux through a closed surface is given by phi equals to charge enclosed divided by epsilon naught. Now phi normally is given by E dot delta S, but when it is a surface we have to take the integration of this thing, and E dot ds equals to Q enclosed by epsilon naught. Q enclosed is the total charge enclosed by the surface S. So this is the Q enclosed, total charge inside the surface. Okay, if the total charge is 0, net flux is 0. If charge is positive, flux is outward. If the charge is negative, flux is inward. Few points. Gauss's law is true for any closed surface, no matter what its shape or size. This is a very important point to remember for MCQ question. Gauss's law is valid for any closed surface, any surface, only spheres, only cubes. So remember, it is valid for all closed surface, not any surface. Any surface can be closed, can be open, but Gauss's law is applicable for only any closed surface. Okay, not only particularly for spheres or a cube, it is applicable for all closed surface as long as it is closed, no matter whatever is the shape or size. Here Q includes the sum of all charges enclosed by the surface. The charges may be located anywhere inside the surface. Okay, it can be here, here, here. You add all the charges, positive and negative, together, and you calculate the net charge, and that is the Q enclosed. Electric field is due to all the charges, but Q is only for inside the surface. Some charges may be outside as well. So electric field, when you are calculating the electric field will be because of this external charge as well as the internal charge. But in the formula, that Q enclosed is only the charge which is inside. Okay, Q enclosed is only due to the charge inside, but electric field is due to all charges, inside or outside, does not matter. The surface that we choose for the application of Gauss's law is called Gaussian surface. Gauss's law is often useful to calculate the electric field for symmetric surfaces. Symmetric surface means sphere, cube, rectangle. Okay, they are considered cylinders, they are considered symmetrical surfaces, and it is useful to apply Gauss's law for such surfaces. Okay, now let's see one question. It is a PU board question. The electric flux over a closed surface enclosing a charged particle is minus Q by 6 epsilon naught, the charge of the particle. So electric flux through a closed surface. Okay, it is calculated, and it is given by phi is given by minus Q by 6 epsilon naught. Okay, so what is the charge? Answer this quickly. Sir, from 23rd we have preparatory, so I am thinking of studying only Brahmastra series. So just now I saw only till ray optics notes are available. Please sir, don't forget to inform the team to upload. Okay, I will inform, and I will upload my missing notes as well. For the previous question, if it is present in the uniform electric field, if it is uniform electric field, only torque force is 0. I mentioned in the lecture. What is the use of continuous charge distribution? In continuous charge distribution is basically where you are, when you are applying Gauss's law, basically charge distribution, if you know the charge density, line charge density, surface charge density, volume charge density, the formula, when you are deriving the formula, it can be slightly easier. That's it. Charge distribution, and also if you are talking about application, charge distributions are more preferred because you cannot calculate the total charge in many cases. Charge distribution, you can take a small portion, you can measure the charge, and then you can find the corresponding formula. Okay, that's why charge distribution are more helpful than knowing the exact amount of total charge, right? Sir, when is the next physics session? Next physics session, I think on Saturday. Next session will be on Saturday. Sir, what is your KCET rank? When I was a student, I was, obviously I have not studied in yes, studies. I am seeing YT comments. Study, okay, I think he is asking for Varija. (14C), yes, correct. It is minus Q by 6, okay, because the electric, this is actually equals to Q enclosed by epsilon naught. So Q enclosed equals to minus Q by 6, right? Now let's move on. Next question. The given figure is related to Gauss's law in electrostatics. Phi equals to Q by epsilon naught, where Q is equals to. So this is also easy question. Again, as usual, second question I am not going to answer the, I am not going to tell you the answer directly. Solve it and mention that in the chat. Mention in the chat for this question. I am not going to tell you the answer. Easy question, see and answer. Okay, not difficult. Sanjana is correct, 14C. Answer 15 now. Answer 15. Anant is saying D, maybe. As I mentioned, I am not going to tell you the answer. So this is a suspense. Answer it. If anyone answers wrong, then only I will tell. If I am not telling anything, that means you are correct. Yes. Sanjana, it is 15. Yes, yes, correct. Okay, 15D is correct. Next, Gauss's law application. Now, if you want me to do the derivation, I can do that. Field due to an infinitely long, straight, uniformly charged wire. Electric field is given by, obviously, if you want me to do the derivation, I can do that. I will just give you the basics first. So, this is a positively charged wire. Wire is, can be positive, can be negative, does not matter. Okay. So electric field is charged wire, charge density per unit length is given by lambda. Yes, it's a board question bank question. Correct. Some of the board question bank questions are actually good. So that's why you should practice them as well. Now, this is the charge per unit length which is given by lambda, right? Now, if you want to find at a distance P, this is where you are trying to find the electric field, and the only symmetrical thing, whenever you are trying to apply Gauss's law, you have to find some symmetry. Only symmetry you can find over here is a cylinder. So you have to draw a cylinder over here. A cylinder will be imaginary. So, and don't draw like me, draw it properly using some scale and pencil or pen, but use scale, definitely use scale. Okay. So this distance is say R, this is R. Okay. Now how to do that? Very simple. Consider the length of this cylinder is L. This is a very small easy derivation, so let me do it quickly. So the length of this cylinder BL, okay, length charge per unit length is lambda. This is an infinite wire, so this goes very long on both sides. So what is the total charge enclosed in this cylinder? The charge enclosed in this cylinder, charge density times the length. So the charge enclosed by this cylinder is given by Q enclosed is given by charge density into length. Right? Now what? So we have to apply Gauss's law. Gauss's law states that Q electric field into ds equals to Q enclosed by epsilon naught. Now what is E dot ds? Now if you see that, why symmetrical surfaces is important for Gauss's law? Because for symmetric surface you say that this point and all the points on the surface of this cylinder, they are all equidistant from the line. Okay, when you calculate the distance of all these points, they are all equidistant. So if the distance is equal, then electric field will be constant, okay, because this is a very long infinite wire. So for that we can say that each and every point on this cylinder will have same electric field as long as the distance is same. Okay, so that means electric field is constant, so magnitude of the electric field is constant, so we can take that electric field outside the integration. If something is constant, it comes out of integration, so what is left inside the integration? Only thing that is left inside the integration is this. And also we do not need to consider the vector sign, okay, because cos theta is 0 over here, so this is the direction of S, this is the direction of E, so all are should be in the same direction, so theta is 0, so theta 0 means obviously cos theta is 1. So E dot ds, now ds is representing the closed surface area. Closed surface area means it is the total surface area. Closed line integral refers to the perimeter. Total closed surface area represents the total surface area. Total surface area of only the curved sides of the cylinder. So what is the formula for that? That is 2 pi r square L. 2 pi r square L is the surface area for a cylinder. And what is Q enclosed? This is already Q enclosed by epsilon naught. So we already know what is Q enclosed, lambda L by epsilon naught. So L cancels and we get E equals to, sorry, one mistake I made, it is 2 pi r L, 2 pi r into L, not r square. So it will be lambda by 2 pi r epsilon naught, or we can simply reorganize it 1 by 4 pi epsilon naught 2 lambda upon r. This is the electric field. Very simple, easy derivation. Okay, this came once in the previous years. Last 5 years, this came once. Now, as you see that, why I have written here 2 to adjust it to be 1 by 4 pi epsilon naught, just to look good. You can keep it 1 here and 2 pi epsilon naught. That is also fine. Okay, this is sometimes important in case of when you are solving questions, because this value is known, 9 into 10 to the power of 9. That's why if you remember this, also here you see that electric field is inversely proportional to 1 upon r. Okay. Now this derivation is not important. Formula is important when is an infinitely charged sheet, charged plane sheet. The electric field is given by sigma by 2 epsilon naught. This is not a conducting sheet. This is a normal sheet. And electric field is given by sigma by 2 epsilon naught. For conductors it is sigma by epsilon naught only. Okay, for other sheet it is sigma by 2 epsilon naught. Okay, sigma is the surface charge density. Okay, easy, no rocket science. Let's move on. This is the electric field due to a uniform charge thin spherical shell. Outside the shell, electric field is given by 1 by 4 pi epsilon naught Q by r square. Inside the shell, electric field is 0. Its graph looks like this. Okay, and it is 1 upon r square. So inside the shell, electric field is 0. So this point represents r equals to capital R, and from here onwards the electric field suddenly increases and then slowly goes to 0. electric field here is 0. Electric field here is 0. Right? Do you want me to derive this? Chitra Streaks is saying question bank with answer. We will try, dear, as much as is possible. Sir, please also provide the notes of this session, because I think I can use this as a last 1 minute page summary notes. Yes, definitely, my lamp, you will get this note after the lecture is over, right? I cannot give you the note with annotation before the lecture. This is a live class. So once the lecture is over, you can definitely download it from the link. It will be shared in our WhatsApp channel. Don't worry, let me complete it. I'm not doing the derivation. This is a very easy derivation. If you need it, you can check my Brahmastra series. There I have done this derivation. Okay, so I'm skipping this derivation for now. It's time for some another KCET PYQs. You are given a dipole of charge. This is a very interesting from 2025 question, and this is based on dipole as well as Gauss's law. You are given a dipole of charge plus q and minus q, separated by a distance 2r. A sphere A of radius r passes through the center of the dipole, okay, as shown in the figure. Another sphere of radius 2r passes through the charge plus q. Then the electric flux through the sphere A is. So they have given you two spheres, but they are asking only the electric flux through the sphere A. So this is a slightly trick question. So they are only asking electric flux through this. Okay, answer it. Even though there are two spheres given, one is A, one is B. Okay, but they are asking electric flux through only A. 0 to q by epsilon naught minus q by epsilon naught, q by epsilon naught. So, okay, Varija is saying this is, I am not Varija, it was my mother's mobile at that time. Okay, Varija, oh, your name is Yashash. Yes, I think you told me, I forgot it, but yes. My lamp, ask him after the class is over, not now. Okay? Guys, answer this question. So you see that only plus q is enclosed by this surface. So this is outside this surface. So this charge does not matter. So it will be minus q by epsilon naught only. So correct answer is option 3. Okay, correct answer is option 3. This is from 2025, Asha's year when he gave the exam, right? Another question, 2024. The total electric flux through a closed spherical surface of radius small r enclosing an electric dipole of dipole moment 2aq is given. Epsilon naught is the permittivity of free space. Another similar question, okay, 2024 as well. So as you can see that dipole and Gauss's law is a deadly combination. So here they have given a dipole inside a surface completely covered. Okay, so in that case total charge is 0, so electric flux will be 0. Okay, the electric field due to a infinite straight uniformly charged wire varies with the distance r as. So electric field due to a infinitely straight uniformly charged wire varies as 1 by r. I am sorry, I am going little fast now. Already 2.5 hours is over, so I am trying to go little fast. We have to solve few more questions. Now those who are wondering for numericals, time for me to solve some numerical questions as well. I will not solve all the questions. I will solve 2 or 3 questions, and remaining I will give you as homework to practice that as well. So uniformly charged spherical shell. So this is the question from 2025. This question came in 2025. So this unit was given wrong in the question. Uniformly charged spherical shell of radius 10 cm has a surface charge density of 16 microcoulomb per meter square. Find the electric field due to the shell at a distance of 20 cm from the center of the shell, 5 cm from the center of the shell. So the radius is given, the charge density is given, so total charge is given by surface area into the charge density, which is sigma. Sigma here is given as 16 microcoulomb per meter square. Okay, surface, what is surface area of a sphere? 4 pi r square into sigma. Okay, now you can put the values or you can leave it here because some values will be cancelled. So keep it here only. So electric field at a 20 cm distance is given by 1 by 4 pi epsilon naught q divided by small r square. Okay, so this is the sphere of radius capital R. You are trying to calculate the electric field at a distance small r. Okay. Now this is outside, right? Case A, point is outside. So for outside, electric field is given by this. Now put the values. 1 by 4 pi epsilon naught into q is 4 pi capital R square into sigma divided by small r square. Okay, so 4 pi cancels and you get 1 by epsilon naught, that is 1 by 8.854 into 10 to the power of minus 12 into r square is 10 centimeter square and small r square is 20 centimeter square. Now both of them are centimeters, both of them are squares, so I am not using any conversion over here. Sigma value is given 16 microcoulomb per meter square. Microcoulomb means 10 to the power of minus 6 coulomb per meter square. Now if you simplify this equation, you will get the electric field at a distance 20 centimeter. I am not doing that, you have to use a calculator to calculate it. Now for B, the point is inside the shell. Okay, so inside the shell, because the distance is given here 5 centimeters, so small r is less than capital R. Okay, that means electric field will be 0. Okay, electric field inside will be 0, outside will be this. Don't forget the unit, Newton per coulomb. Okay, so calculate this. Very easy question. Only thing, one mistake that was done by the board, they have, instead of giving microcoulomb, they have given micro centimeter to the power of minus 2. That is a mistake from their side. Anyway, let's move on. One more problem. 2 point charges plus 5 microcoulomb and minus 5 microcoulomb are located at A and B separated by 0.2 meter in vacuum. Yes, Nagaraj came late today. My lecture is almost over, Nagaraj. 2 point charges, 5 microcoulomb, but try to solve the questions. 2 point charges, 5 microcoulomb and minus 5 microcoulomb are located at A and B separated by 0.2 meter in vacuum. So here we have, these are very common questions, A and B. Okay, one is plus 5, another is minus 5. And the distance is 0.2 meter, means 20 centimeter. What is the electric field at the midpoint O of the line joining the charges? What is the electric field at the midpoint? So electric field at the midpoint, so from the positive charge it is 0.1, from the negative charge it will also be 0.1. Now if you see that both charges are magnitude wise same, so positive charge electric field will be in this direction, negative charge electric field will be in the same direction. So if you consider this, you will know that electric positive will be equals to electric negative, and that say equals to electric E. Okay, so net electric field at midpoint is basically 2 into E. Both are in the same direction. So the net electric field will be basically addition. So addition means 2E. So now calculate 2 into K Q by R square. Right? So 2 into K is 9 into 10 to the power of 9. Electric charge is 5 microcoulomb, means 10 to the power of minus 6. And distance r square is 0.1 whole square. 0.1 means 1 into 10 to the power of minus 1 whole square. If you are afraid of handling points, or if you are too much dependent on calculators while using point values, always convert points into 10 to the power of minus 1, minus 2 based on how many decimals are there. That is much more easier to handle than squaring a point, and if you make a mistake, it will cost you 5 marks. So don't make that mistake. Okay, 45 into 10 to the power of 3 divided by 10 to the power of minus 2. Okay, so you get 45 into 2 is 90, 90 into 10 to the power of 5, or 9 into 10 to the power of 6, and unit is Newton per Coulomb. Okay, so the electric field at the midpoint is 9 into 10 to the power of 6 Newton per Coulomb. If a negative test charge of magnitude 2 nanocoulomb is placed at O, what is the force experienced by the test charge? So if you place a negative test charge at this point, first of all, negative test charge will experience a force in the direction opposite to that of the electric field. So this is the direction of negative test charge. Electric force is given by, so this is part A, this is part B. Force is given by Q into E. Q is 2 nanocoulomb, and electric field we have already calculated, 9 into 10 to the power of 6, so it will be 18 into 10 to the power of minus 3 Newton. Okay, no rocket science, just understand the problem by drawing the diagram, find the direction of electric field, then once you have understood the meaning of the problem, just apply the formula step by step and solve it. As simple as that. Sir, this year expected numerical from chapter 1 or chapter 2 according to you? So according to me, this year you can expect numerical from chapter 2, but it is very difficult to predict. Very difficult to predict according to me, because last year first paper numerical question came from chapter 1. So I guess maybe this year, but there is no direct clear pattern. Okay, sometimes it is alternate, sometimes it is happening 2 years after. Okay, but if this year numerical question comes from chapter 1, there will be high chances next year. But this year it is very difficult to predict which chapter we are going to expect the numericals. Okay, sometimes it is even 3 years back to back, they have given questions from chapter 1 and 1 year chapter 2. Chapter 2 numerical questions are slightly less likely, but we have seen that as well. But in my opinion, this year might be you will get a derivation from this chapter, especially dipole related one, and one numerical question from your potential. Okay, but I may be wrong. Now this question I am not going to solve. 3 charges, I will give you a diagram only, solution you have to do it yourself. 3 charges each equal to plus 4 nanocoulomb are placed at 3 corners of a square of side 2 centimeter. Find the electric field at the 4th corner. So here we have a square, okay, plus 4, plus 4, plus 4. You have to find the electric field at this corner. Now how to approach this kind of question? This kind of question is very common, especially pre-board exams, maybe not super in board exam, but we have seen pre-board this type of questions are very common. Okay, now how to solve? Maybe you will see this question. This is a particular question when all the charges are same. Okay, so first of all, this plus will have an electric field in this direction, this plus 4 will have an electric field in this direction. Okay, the magnitude wise they will be same. Magnitude wise these two will be same. Now this one will have an electric field in this particular direction. Okay, so these 3 electric fields are completely 3 different directions. So after calculating, you cannot simply add them. So what you have to do after you calculate this electric field? So this electric field is nothing but, so suppose this is A, this is A, okay, this is A, this is A. and the diagonal is a root 2. Okay, diagonal of a square. So electric field, this one is given by this one and this one is given by k q by a square. Magnitude wise same, right, but direction wise they are perpendicular. Their resultant will be along this diagonal only. The resultant will be along this diagonal, and that value is e root 2. Two equal vectors, equal and perpendicular vectors, their resultant is given by square root of e square plus e square, which is nothing but e root 2. Okay, so you calculate the e root 2. This electric field will be in the same direction, which is say given by say E3, suppose E3. So now once you calculate e root 2 and E3 separately, what is E3 by the way? E3 is nothing but k, charge is same, distance is different, so it will be a root 2 whole square. Okay, so this is the E3 electric field. Now these two electric fields are in the same direction, so you can simply add them. So the net electric field is given by e root 2 plus E3. Okay, that is how you can calculate the net electric field. Okay, so this is a very typical question. Practice it. I am not solving it so that you get some level of practice. When if you solve this question, if you can solve this question, you are in a good place to get good marks in board exam. Last question, again I am not going to solve it, easy question. A polythene piece rubbed with wool is found to have a negative charge of 3 into 10 to the power of minus 7 Coulomb. Estimate the number of electrons transferred. So estimate the electrons transferred, it is 6.625 into 10 to the power of 18 into this value, that is 3 into 10 to the power of minus 7. Okay, so this is the number of electrons transferred. Again almost 20 into 10 to the power of 11 or 2 into 10 to the power of 12, almost. Okay, almost this is the value. Slightly less than 20, but I am not using the calculator. So this is how you can calculate the number of charges. Is there a transfer of mass from wool to polythene? This is a very interesting question. And from which to which? So rubbed with wool is found to have a negative charge. Negative charge means it is gaining electron. Okay, so polythene is gaining electron, wool is losing electron. Polythene is found. Okay, polythene rubbed with wool is found. That means polythene is the main object. Okay, wool is something which you are rubbing with. So polythene is gaining electron, wool is losing electron. So electrons transferred from wool to polythene. So wool to polythene. Okay, so this is how you can even determine the direction of electron transfer. So electrons transferred from wool to polythene. What about, is there a mass transfer? Mass, yes, obviously if electron was transferred, mass is also transferred, but mass transfer is very, very small and negligible because the mass of electron is very small. Okay, mass of electron is 9.1 into 10 to the power of minus 31 kg. Okay, so this mass is very small, so we can ignore the mass transfer. Now, formula sheet as promised. So the formula sheet for this chapter, Coulomb's law in electric field. So entire summary of the chapter, electric force, Coulomb constant, epsilon naught, how to apply the same formula if there is a directing medium present. Now what about electric field, formula for electric field due to a point charge, force due to electric field. Okay, next is dipole, the formula for dipole moment, electric field on the equatorial axis, equatorial on the axis, equatorial plane, there is a negative sign, torque acting on a dipole, P cross E, tau equals to P sin theta. Now potential and potential energy of a dipole and potential due to a dipole we will study in our next chapter, but I like to keep everything related to dipole in a single sheet. That's why I have given you dipole in this chapter only. Okay, so these two formulas we will learn in our next chapter, but if you want to remember anything about dipole, just look into this page. Everything about dipole you can remember. This is a very handy guide to remember everything before exam. Okay, so dipole potential energy and potential due to a dipole, everything at one place. Next is next is Gauss's law and application, everything in one place. Electric field, infinitely long. Gauss's law formula is obviously here. Okay, electric field, infinitely long charged wire, field due to a charge infinite sheet, field due to a infinitely charged spherical shell. Okay, outside, inside, as well as your diagram. So these are the all important formulas at one place. If you keep this sheet with you, you can revise the chapter in less than 5 minutes. Now if you are here, if you want to practice more question, let me know. I have 5 more questions to solve. Sir, when you do current electricity? So after this lecture, I think the schedule was shared in our WhatsApp channel and also during our live launch of this series. So current electric potential is next, then current electricity. I don't remember the next lecture will happen on this Saturday. Okay, and thereafter there is a small break because of your PU2, pre-board 2. Once your pre-board 2 is over, after that we will start with current electricity and moving charges and magnetism. That we will cover till end of January, and then we will start with the next chapter, ray optics. That is in my agenda, ray optics, and then we will decide what chapter to do. Okay, if you have any other suggestion, you can mention that in the comment. Okay, so do you want me to? Okay, Ananda is saying we want. What is your opinion about this year blueprint? So this year blueprint is little confusing. Last year, but I will say that at least they have mentioned, they have not tried to confuse you by giving you 3 blueprints. Okay, they have given you only 1 blueprint, but they have not mentioned from which chapter you are going to get a 5-mark derivation, from which chapter you are going to get numericals. But somewhat it is predictable. For example, obviously there will be a numerical from alternating current. There will be no theoretical question. Current electricity, you are going to get a numerical as well as a theory question. Okay, first 2 chapters, 1 theory, 1 numerical. That is guaranteed. Now wave optics and ray optics, 1 numerical, 1 theory. Okay, so this is understandable. Otherwise there is not much confusion like last year, that which blueprint they will give you, what type of questions will come. So that type of confusion is not there, at least. So they have given a master blueprint. So practice questions, I was supposed to give you is a practice question, but if you want, I can solve it in this lecture itself. A point charge, these are KCET level question, but not PYQs. A point charge A of charge plus 4 microcoulomb and another point charge B of charge minus 1 microcoulomb are placed in air at a distance 1 meter apart. Then the distance of the point on the line joining the charges and from the charge B where the resultant electric field is 0. So here we have 2 charges, okay, plus 4. Okay, let me do one thing. I have 5 questions, so I will solve 2 questions, 3 questions. 2 questions I will give you as homework. Okay, so that you have to do it yourself. Okay, deal. So 1, 3, 5 I will solve. 2 and 4 you have to solve as your homework. So plus 4 microcoulomb, plus 4 microcoulomb and minus 1 microcoulomb are separated by 1 meter. Okay, so then the distance of the point on the line joining the charges and from the charge B. So this is A, this is B. So line joining the charges, suppose this is the point, say P, where the electric field is 0. You have to find this distance x. If this distance is x, this is 1 minus x. We are saying this is in meters. Okay, in meters you have to calculate. Now you don't, I think the option is not correct anyway. I will see that. Okay, option is not correct. Options are not correct. Don't go for the options. Solve it and tell me the answer. Okay, so electric field is 0 at this point. So electric field is 0 at this point means net electric field here is K into plus 4 divided by, so due to plus it will be in this direction and due to minus it will be in this direction. Okay, sorry, one mistake. It is, options are correct actually. The point will not be, this is plus 4, this is minus 1. Okay, this is A, this is B. Now if you consider this any point between these two charges, okay, due to positive it will be in this direction, due to negative it will also be in this direction. So definitely the point is not located between these two charges. The point must be located somewhere here, outside the charge. Okay, so outside the charge, the point where the electric field is 0 is located. This is called null point also. Okay, so null point is definitely located outside. Say this distance is x, and this distance will be 1 plus x. Electric field to positive will be away, electric field to negative will be towards. So this is the point where electric null point is located, and that means we can say that K into 4 by 1 plus x whole square equals to K into 1 divided by x square. So this is a formula you can remember. Okay. So x square by 1 plus x whole square equals to 1 by 4. Okay, take square root, we get x divided by 1 plus x equals to half, or 2x equals to 1 plus x, or x equals to 1 meter. So correct answer is 1 meter. So this distance is 1 meter. Correct answer is option A. Now how to remember it? You can remember this way, that if both charges are opposite sign, the null point is always outside. The null point is always outside, and it is closer to the smaller charge. It is always closer to the smaller charge. Okay, so because this is smaller charge, null point will be always closer over here. Okay, and the formula is the distance that you are trying to find plus L plus x whole square equals to Q small divided by Q big. Okay, this way you can calculate. Now next question. Next question I will give you as a homework. So download the PDF. If you want to download the PDF, you go to our WhatsApp channel, okay, and download the PDF after the lecture is over. Solve question number 2. Question number 3. Another very interesting question. Two small spheres, each having the charge plus Q. Two small spheres each having the charge plus Q are suspended by insulating threads of length L from a hook. This arrangement is taken in space where there is no gravitational effect. Then the angle between the two suspension and the tension in each will be. Very interesting question. Two small spheres each having the charge plus Q, okay, are suspended by insulating threads of length L. So we have two charges, okay, plus Q and plus Q. Those are suspended from two insulating threads. Now if you take this arrangement in space, what will be the angle between these two? Angle is very easy. The magnitude might be tricky. Okay, so easy question, by the way. Question is very easy if you understand. So if you take this arrangement away, so basically it is like a gold leaf, but they are like this. If it is on earth, if the system is on earth, you have to calculate, use the gravity, okay, then calculate the tension, then there is some gravity over here, some tension over here, some repulsive force over here, and it will be a three-body problem, three-force problem. But here, when you take this system in space, gravity is gone. Gravity is gone. That means only thing that is important is this repulsive force. So when these two repulsive forces are acting on these two string, they will find only one equilibrium position, okay, and the tension will arrange such that this arrangement has the least amount of force. So that means they will arrange themselves like this. So this is L, this is also L. Okay, so they will arrange themselves because there is no gravity to make any angle. They will straighten up, they will flatten up. Okay, so they will flatten up means the angle will be 180 degrees. Okay, what is the net distance? Net distance is 2L. So net distance is 2L. So this is a very interesting case. Don't think this is difficult. This is actually easy question. So now Coulomb's law, the tension of the wire is exactly equals to Coulomb force. What is Coulomb force? 1 by 4 pi epsilon naught Q into Q divided by 2L whole square. Okay, so Q square divided by 2L whole square. Angle is 180 degrees because no force to balance them. So they will expand as much as possible. So angle is 180 degree and force is 1 by 4 pi epsilon naught Q square by 2L square. Okay. So see, this is a very typical KCET level question. This question never came in KCET, but this level of this question is very much apt to KCET level. This question again you have to download and solve. I will not tell you the answer. Question number 5. Two charges 4Q and Q are 3x apart in air. A charge capital Q is placed at a point on the line joining so that the system of these three charges remains in equilibrium. Then the distance of Q from 4Q and the value of QR. So here we have 4Q and Q are 3x apart. So their distance is 3x. Okay. A charge capital Q is placed at a point on the lining joining the charge so that the system of these three charges remains in equilibrium. Okay, now say we have put a charge in the middle, okay, so that the system is in equilibrium. Somewhere, we do not know. Okay, then the distance of Q from 4Q and the value. So distance of 4Q, say this distance is, so this distance, okay, I cannot say X, so this is R. This is R, so this will be 3x minus R. Okay, now the system is in equilibrium. System is in equilibrium means if you take any one of the charges, okay, the net force acting on this charge will be, so net force due to positive charge will be in this direction and this capital Q will be in this direction, and from there you can calculate the equilibrium. But first we will calculate small value of capital Q, okay, and then small q, distance. Okay, so how to do that? So first of all, this will be negative obviously. Why it is negative? Because if it is positive, then net force on this capital 4Q will be always away from. So they will add up. They will not cancel each other. They will add up. So if it is a negative charge, only then the system will achieve equilibrium. Okay, because these two charges are positive. These two charges are positive in nature. Okay, so what is the force on this plus 4Q due to this? The force due to positive small q is given by 4Q into Q into Q divided by total distance, that is 3x whole square, and there is a Coulomb constant K. Does not matter, it will cancel anyway. What is the force between these two charges? Force between these two charges must be equal and opposite so that the system remains in equilibrium. So it will be K into capital Q into 4Q divided by R square. So from here we will get one equation. So 4Q cancels and we get q by r square, k also cancels, q by r square equals to small q by 9x square. Okay. Now obviously we do not know the value of capital Q or R, so we need to use one more equation. So for that we will use the equilibrium of this charge. Equilibrium of this charge. So how to do that? So force between these two charges. Force between these two charges, 4q into q by r square, and force between these two charges, they also has to be equal, right? Because the system is in equilibrium, so the force, net force acting on this capital Q will also be 0. So whatever force acting on the left hand side, same force should be acting on the right hand side. So this force is k 4q by q by r square, and this one will be k into small q capital Q divided by 3x minus r. So try to understand these problems. These are very, very fundamental problems. Okay, from here q cancels, k cancels, and we get 4 capital Q by r square. Also q cancels, this is also cancels. Okay, so we can calculate r from this equation. So 4 by r square equals to 1 by 3x minus r whole square. Now if you take square root on both sides, we get 2 upon r equals to 1 by 3x minus r. Now cross multiply, 6x minus 2r equals to r, or 6x equals to r plus 2r, that is 3r equals to 6x, or r equals to 2x. So r equals to 2x. Now put that value over here, q by 2x whole square equals to q by 9x square. 2x square means 4x square. Now x square cancels, we get q equals to 4 by 9 small q. Okay, so distance is 2x and it is 4q by 9. Now obviously it is a negative. Why negative? Because as I mentioned, charge must be negative. So minus 4q by 9 and 2x is the answer. Okay, tricky, but this is a slightly difficult level question of KCET. This kind of question also might come. Kaushik Shetty. Hi Kaushik Shetty. My time is over. It's almost 3 hours and it's 9 p.m. now. I hope you enjoyed today's session. If you have any doubt, mention in the comment section. Sir, for question 1, can you equate both charges A and B, R equals to 1? R equals to 1, no, R equals to 1, you have it is outside, right? So R equals to 1 is not there. You cannot equate with R equals to 1. R is different. You are trying to calculate based on this is a x distance, this is 1 plus x distance. So you cannot use R equals to 1 for both charges, right? It is a null point. Null point means electric field is 0. So you cannot simply find the force between these two charges. You have to use null point equation. Null point formula, you can use this one. Okay, this is easiest formula, and if you use it, you can solve it directly, right? Okay, Ananta is saying thank you everyone, those who joined and stayed with me till the end. Okay, I will see you on Saturday, another live. Till then, bye, and don't forget to subscribe to our channel if you have not subscribed, and join the WhatsApp channel. The PDF will be shared there very, very soon, and obviously see you in the next lecture. Till then, bye.